Very good evening, class. Can you guys hear and see me? Very good evening, Ashwin. Thanks for confirming, Nilanjan. So I remember you guys were not in the last class. I think that was on Saturday morning. Nilanjan, you were also not there. Ashwin, I remember you were also not there. What happened? Weekend enjoying, huh? Oh, okay. So you guys can tell to Ansul that you guys are facing the having some situations. So they might he might schedule something according to your time, right? If it is like for most of the people, so I think yes, we can schedule it for different time also. Ah, okay, you are helping your family. Is everything okay in your family, Ashwin? I hope everything is good, right? Oh, okay. I got it, got it. Yeah, I think yeah, the festival seasons is coming, right? Like Dasara and Diwali is coming, so house cleaning and shopping is very necessary. That's what I also have to do. Okay, so I think we'll wait for 2 or 3 more minutes and then we will start. So I hope like you guys have practiced it, right? Because the topic which we are discussing is very important, and I think after saying important, these topics are also very complicated, right? Like the data structure, binary search, and these topics are very complex as well. Hey Ankit, I'm doing good. What about you? Great. So as I was saying that I hope you guys are practicing it because we have like whole Saturday you got, and I think Sunday also you got, right? Morning, whole Monday, like till now you got. So I'm expecting everyone to please practice it because these concepts are that much complex. If you will not do practice, you will very easily forget it. And see, the reason why I'm saying to do more practice because like these questions, these type of concepts, they are only asking in interviews, like the problem solvings or in interviews only. So that's why once you join any company, I have not worked any of these concepts till now. I have not used anywhere any searching algorithms like binary search because internally all languages are already implementing it. So as a developer, we are just quickly using inbuilt functions and just creating our product, just finishing our project or completing the feature. So that's why these concepts are actually very easy to forget if you're not doing practice. I won't lie. The questions which we are going to discuss it today, I think those are very hard questions as well. Some of them are very hard. I think I checked. There was one question. I think a split array, something like that. That was very hard questions. You guys won't believe. I have spent whole weekend actually, whole Saturday and Sunday and some time of Monday also to understand these questions to you guys to explain. So I will try today my 100% or more than 100% to explain these things. And I'm also very sure like today you guys can feel what is happening in these questions or I'm not able to understand. So at that time, I'm saying just be in the like keep some patience and write your questions in the chat. I will not go ahead without explaining these things. If I've explained with one example, but you guys are not able to understand that, I will try to explain with other examples. Okay, and because of that we might not be able to complete all of the questions today, but I will try to explain the logic, and as well what the question is asking, because there are some of the questions in those 6 questions you guys will not be able to understand what is the question exactly. So do not like lose hope. We all will do together this whole 3 hour session, and I will also try to explain it as much better I can do that. And yeah, I was saying like there could be some of the places where you guys feel what is happening, I'm not able to understand, I don't know what is happening here, I have to like stop it. So do not like feel like that, just write your question here, and I will repeat these words after 1 hour also, because right now you guys will remember, but after 1 hour you will not remember this thing. So I will repeat at that time also. Okay, guys. So let's start today's session, because today we are here going to have like I think 6 questions we have. Yeah, these are the 6 questions, and some of the questions in this I think very hard. I think I remember one of the question while I think splitting an array or might be subset sum between A and B. These are very hard questions, right? So like if any of the interviews people are asking questions like this, they will definitely give you 45 minutes to think about them, to think about the strategies. But if you guys are already doing these questions, practicing it, like today we are doing it in this class, right? We will understand some of the concept about this question, correct? And then you guys, if you guys remember those concepts, and you guys practice more question with these concepts, then these questions will become very easy for you, right? So that's what today we will also try to solve some of these problems. But at the end of class, I will try to explain all of the questions to you with the logic, like the theoretically all the question with logic. And because we already have a code for that, they have already provided in the slide. So once you will understand the logic, what is happening, then only you can understand the code or you can implement the code. So that's what my today's agenda is, to explain the questions to you or also explain the logic behind that. Okay, so that's what we will do it today. Let me see in meanwhile if there are any questions from you guys. How often we use DSA in company as compared to development? Like as I was saying, Ankit, so very less we use DSA's concept, because we whoever has created language, they those people only use the DSA, because while developing the compiler and the languages, they already using the best sorting, best searching, those algorithms. So that's why and yeah, DSA we use while in interviews. Mostly the people ask DSA based question in interviews, I feel. So I got less time to practice because of office for 6 days, so I'm trying to get some time in Sunday. Yeah, Nilanjan. So because I know because see, these type of problems you can spend daily. Like you can choose. See, I will suggest to everyone these type of problems. Like 6 problems are there. All 6 problems are having different ideas. Correct. So you guys can daily take one problem and think about it. How like you can today we will explain all 6, but in remaining days you guys can take one problem from here, and in the next, like before sleeping or at in the whole day, anytime, just give 1 hour to one question. Definitely, see, first you will understand better this question, and then you will also understand, like you will visualize how the things you like, whatever written in the code, you will visualize those things, right? And then I'm saying to you, if you will do this 15 or 20 days with each questions, so I think when you will be in the 21 days, I think automatically a lot of things will be coming into your mind. You do not need to see any other code. You do not need to like you do not need to write some of the things. Automatically things will visualize in your mind. So that's what I will say to everyone. Also to Nilanjan, spend daily, like give 1 hour through each problems. We already have the code. I will also explain today the logic about it. I will also explain the problems. When you will have all these 3 things, you just now you need to use your brain to get more than 200% from that question. So that's what everyone has to do that from today. Okay. It's a part of DSA when something is coming in your mind. It's part of DSAs and it's in your mind. Okay. Yes, spitting one is hard. Yeah, spitting one is really hard actually. So I have worked with Polymer. Okay, Polymer.js. I have not worked with that. So thank you for inspiration. Yeah, please see. This is for everyone actually. Please take one questions and like try to practice this. Okay, so guys, we won't waste today much time on talking. So we'll start understanding these questions because these questions are really like interesting one also. Once you will say, once I was trying to solve it, it was very interesting. So we'll see that. Okay. I have applied in many companies. They ask for experienced candidate. They ask that what tech stack do you know, and I'm confused that someone hires freshers or not. No, actually, they hire. They hire. There are some of the openings where they hire freshers also. But yeah, like you are right. Like most of the organizations I've seen in the LinkedIn, they are, I think, mostly hiring for the experienced candidate. So we can talk about it more, yeah, later on, or in our doubt session. Okay. Okay, guys. So before starting these questions, let's quickly. Okay, let's see last question of Bharat also. How can we know which question using binary search approach? Because we problem not shown anything about what approach we'll use. Yes, that's also very good questions. There are some of the terminologies. There are some of the terminologies where you can see that only binary search solutions are going to use. So I think this is for everyone. So so if somebody was asking like maximum of number or minimum of maximum number or maximum of smallest number or minimum of largest number, these type of terms, whenever, like I think we also have one of the questions where we are going to get these terms: minimum of smallest, minimum of maximum number, or maximum of minimum number. These type of terms, whenever we are using, most of the scenarios I have seen, the people are using the binary search there. Okay, this is one trick which I think this is good for everyone. They can remember this, where you guys can use the binary search. And in other parts, whenever I think we have to find, like we have one sorted array, and somehow we have to find some elements between those elements, elements in the array, or we might need to find a range between numbers, or we have to find there is one number, we have to find the smallest number on that or greater number than that. These type of questions we automatically think like might be the binary search could be the solution there. So I personally feel I will also find some cheat sheet. There would be somebody has created a cheat sheet also, which will tell you that if you see these type of terms in the questions or these type of patterns, so on those scenarios, you guys have to use the binary search there. Okay, so I will try to find out that cheat sheet also. Okay, guys. Yeah, so let's now move into topic, and I think we can discuss about these more things in our whenever we have, I think we have doubt session also, so we can talk about it. Okay, guys. So let's start understanding from our last topic. Okay, for like the linear search and binary search. So linear search, we are very clear that in the linear search we are going to iterate all the elements and then trying to find out the target, right? That's what the linear search we are doing. We are trying to iterate in each elements, and then at the end we are comparing with the target. If any element is matching, we are saying yes, it's match, otherwise try to return -1. But in the binary search, what we did, rather than iterating whole array, we just pointed out the first mid element, just taken one element from the array, that is the mid element, and then what we are doing, we are trying to compare that mid element with target. If the mid element is greater than our target, then it means we have to go to left side. If the mid element is greater than target, then we have to go to left side. Everyone remember these things. If our mid, the element, or you can see, everyone can take one thing. If or they can take mid or they can take target, anything, any one word you have to remember in your mind. If you are saying if your target is greater than mid, then if your target is greater than mid element, then you have to go to which side? If your target is greater than mid, you have to go to right side. If your target is greater than mid, you have to go to right side. Or if your target is less than mid, you have to go to left side. So everyone, see, I could like this thing could be confusing, but think in your mind. Think in your mind that what term you are taking, because we have to compare two things: target or array of mid. So pick one thing, whichever you want to take, because every time you are going to apply that into your if loop, or according to that you are going to increase left or right. So that's why do not like try to memorize as I am saying. I can take sometime array of mid, or I can take anytime target. So you also try to figure out in your mind as I am trying, that if I am taking target, if my target is greater than a of mid, if my target is greater than a of mid, I need to now go to left side. Correct, because our target is bigger or array mid is smaller. So I have to go to which side? Right side, left side. I think that we can visualize with the visualize with the array also. Correct. But yeah, we have to see the core concept is we have to move, and in the sorted array, because we are incrementing. So if the number is greater, so we have to go to right side. If the number is lesser, we have to go to left side. I think this is better way to remember these things. Okay. So that was about the linear search and binary search. Okay. And there is two more things which we are going to discuss, which we have seen so many times, the known as upper bound and lower bound. Upper bound and lower bound. You will see lot of problems today we are going to solve. We are going to use the concept of upper bound and lower bound. So I want to explain first to you guys what is the meaning of upper bound and lower bound. Okay, guys. So for that, we will move into a slide. Okay, guys. So for binary search algorithm, try to create your visualization. Just try to take one array and try to find one target, and according to that, you have to go to left or right. Okay. Can you, sir, please repeat again Saturday's last question? Sure, Ritik. We will see it in the at the end. If we got the time, we'll repeat it. Otherwise, we'll see it in the doubt session. Okay, on Tuesday. So, guys, most of the time we have heard the lower bound and upper bound. This is a mathematical term actually. Lower bound and upper bound. So let's take an array. Okay, so let's take one array 2, 4, 6, 6, 8, and 10. We have taken the 5 elements. Okay, so see, lower bound and upper bound, by definition, they say it the minimum and the maximum position where a element can be inserted. Minimum and the maximum position in an array where an element can be inserted without disturbing the ordering of element, without disturbing the ordering of element. Okay, so lower bound is the minimum position where a new element or existing element can be inserted, or upper bound is the maximum position where a element can be inserted. Okay, so now let's take example of there is one element n is equal to 3 which we want to insert into this array. Into this array. So अब देखो, what will be the minimum position where we can insert this element without disturbing the ordering of array? So that position will be first index. Let me write the index also: 0, 1, 2, 3, 4, 4, 5. See the minimum position where we can insert this 3 without disturbing the ordering, that would be the first position. Right, guys? We can insert this 3 here. Am I right? Tell me in the comment. Without disturbing the position of ordering, right? So the lower bound would be 1 here. Will it be 0? No. In the 0, already 2 is there, and 3 is greater than 2, right? 3 is greater than 2. So we will be inserting at the first position, correct? So that's why the lower bound will be 1. And now let's talk about the upper bound. Upper bound is the maximum position where we can insert the element. So I think the maximum position is also 1 here, because after 2, 4 is only coming, right? And the 4 would be the maximum position, correct? So that's why the maximum position for 3 would also be 1, because both places at the both bound, upper bound and lower bound for the element number 3 would be same, because that would be the maximum position where we can insert a new element without disturbing the ordering of our array. You can see we have to just insert 3 here, and now you can see without disturbing a ordering of that array. That's why upper bound and lower bound and upper bound will be 1. Now let's take one more example. If we are taking 6, so what would be the minimum position, like the lower bound where 6 can be inserted? That would be the second index. On this index only 6 could be inserted. Correct? So the lower bound, if an element exists in the array, so the first occurrence of that element would be the lower bound. Okay, so the lower bound for this element 6 would be 2, but the upper bound would be, guys, the next element, the next position, the 6. If you want to insert 6 here, so the next position of this would be the upper bound for that, and that would be 4. Upper bound would be 4. Okay, guys, so that is the lowest and maximum, like the minimum and maximum position for inserting a new element in the array. Or if the element exists, if the element already exists and we are looking for lower bound, so the first occurrence of that element would be the lower bound, and the upper bound would be the next greater element of that. So because the next element from the upper bound could be inserted at this position, at the 4th position. Okay, let's look for any other elements. Okay, so let's see meanwhile any questions we have. What Dipanshu is saying, what if we had 4 to insert? So if we have 4 to insert, because 4 already exists and is equal to 4, so what would be the minimum position? Minimum position would be same, because element already exists. So at this position only we will insert. So the lower bound for 4 would be first index. Okay, and now the upper bound for 4, because 4 already existed in this position, now we have to look for the next position, and the next position would be 2. So the upper bound for 4 would be 2. Okay, let's take upper. Deepak is saying, I don't understand, can you explain again? Sure, yeah, I'm trying to do that. 4 I believe, then for, okay, basically lower and one bound means repeat NaN null or undefined. So the NaN null or undefined, they would be like based on the condition, we would be like we would be checking it, and I think for all of them, if we really want to insert them, they all will come at the 0th position, because they all will be less than 2, because we are comparing it here. Right? So not a number, if we are saying that not a number is less than 0 or null. By the way, if we really want to insert these things, I think we will not insert it. We will stop it there. We will say that this is not a number. We cannot insert it into the array. Right, Dipanshu? So we will return -1. Or like simply throw the error there. Okay? See guys, let me explain it again. The lower bound and upper bound. So lower bound is the lowest position or the minimum position in the array where an element can be inserted. Correct? Or the upper bound is the maximum position where the element can be inserted. That is the upper bound. Ab dekho, if we are taking n is equal to 3, up 3 does not exist in this array. And now 3 has, now according to the sorted array, 3 has only these two between this position, right? 0 and 1. Between these positions, 3 could be inserted. Correct? That's the only position. We cannot insert any other places this 3, right? So now 3 has to be greater than 2 or less than 4. Correct? So that's why the correct position, the minimum position for 3 to insert after 0. So the minimum position would be 1 only. That would be the minimum position. Correct? And now if we talk about the upper bound, if we talk about the upper bound, the maximum position where we can insert, so the maximum position would also be 1, because if we will insert 3 here, 4 will be at the second index. 4 would be at the second index, right? So that's why the maximum position also for inserting 3 would be the first position. Okay, Now, if we take the example of n is equal to 6, correct? If we take the example of n is equal to 6, correct? So the minimum position, where, see guys, again, these are very mathematical terms and you guys might be little bit confused, but try to understand what I'm trying to explain here. Okay, so see, for the 6, if we talk about n is equal to 6, this element already exists here, so the lower bound for this element would be the first position where this element has been inserted. वही तो बोला, lower bound is the minimum position where an element can be inserted or existed or the existed. If an element is already exists in the array, so that would be the minimum position, right, where this element has been existed. So that's why if the element already exists in the array, so lower bound would be the element, lower bound would be the first place or the first occurrence where that element exists, because this is only the minimum position. That's why this element existed. This array is already sorted. This array is already sorted. This 6 cannot go anywhere else. This 6 can only be inserted in this place. Correct? And now if we talk about the upper bound would be the next place where the element can be inserted. See, 2 and 3 has already been inserted. Now the next 6 which could be inserted would be at the fourth position only. Would be at the fourth position. Right, guys? Same goes for 4. If the element already existed, so you means where that element existed, it would be the minimum position, first occurrence, or the maximum position would be the next element for that. Only at that place the new element can be inserted. Right, guys? So that is an upper and lower bound. So now everyone tell me about the 10. What would be the lower bound and what would be the upper bound for 10? Yes, we cannot change the ordering and change position. Okay, there are 2 6. That's why 6 is 4. Yes. So Dipanshu is saying, Vishal is saying, see, no, tell me like lower and yeah, like that, like Suraj has written. So lower bound would be the 5. Suraj is saying, and upper bound would be 6. Let's see. So so now 10 has already exists. So for 10, the lower bound would be 0, 1, 2, 3, 4, 5. That's right. The lower bound would be 5 and upper bound would be 6. Totally right. The 6, that would be the 6th position where we can insert the 10. Correct? That's totally right. Okay, let's take any other example. Then we can talk about it. Yeah. Let's take very quickly other example. Let's take a new slide. So let's take 0, 1, 2, 3, 3, 4, 5, 5, 6. Right? Let's talk about let's talk about 4. Let me write also the indexes 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Tell me the indexes for like lower bound and upper bound for 4. So look at this thing 5 and 6. Right. 5 and 6. The first position where element exists and the second position if element exists, right? Yes, this insertion can only be done on sorted array. Yes, we are only talking about lower bound and upper bound in the sorted array. Okay, so let's talk about. I think we have not missed any elements. So let's remove this 2. That would give us like better example, right? So index is 2, 3, 4, 5, 6, 7. Sorry for this mess, guys. Just trying to create little bit complex example. So like Claire, tell me about 2. If lower bound and upper bound, what would be for 2? So Arad is saying 1 and 2. And people are saying, Ashwin is saying 2 and 2. Suraj is saying 2 and 2. Okay, a lot of people are saying 2 and 2. Let's see. So yeah, it will be inserted after 1. Yeah, it will take this place. Correct, 2 and 2. That's totally right. Right, 2 and 2. Correct. So see, Hariharan, I will quickly explain. I think this is not good. You have to join it at the time. Otherwise, see, at the end, we will miss some of the topics if I will repeat it again. But yeah, please join it at time. Okay, so what I said, Hariharan, that there are like some of the questions where people are like, where you will see we are trying to calculate lower bound and upper bound. So I want you to like first tell about the lower and upper bound, and I will also show you the code. How will we do that? So in the code, while we are doing, we should not have to go to the lower bound and upper bound code. Okay. So see so what is the lower bound and upper bound? The minimum place where a new element can reside. A new element or existing element can reside in the array, a minimum place, or the upper bound would be the maximum place where an element can be reside. Okay, so let's see. If we talk about the 4, so 4 already reside. So this could be, and the first occurrence from the left side, this is the first occurrence. So it means this is only the minimum place where 4 is residing. So that's why lower bound would be the 5, lower bound would be 4 for it. Lower bound would be 4 for it. And now, if you want to insert a next 4, so what would be the next position for that? That would be the next element after 4. So that would be the fifth index. So that's why upper bound would be fifth. Same goes for 2. So now 2 does not exist. But where 2 will be reside, if we want to insert 2, what will be the minimum position where 2 could be reside? This would be after 1 only. After 1 only. So that's why lower bound is also 2 and upper bound is also 2 for this scenario, because 2 does not exist. So that's why upper bound will also be the next element, like after 1, that would be 2. So lower bound and upper bound would be 2 for that. Okay. Okay, so now let's talk about the coding. If you want to code this lower bound and upper bound code, then how we will do that? Okay, so let me share my screen. So everyone, is that now understood the lower bound and upper bound? If I will give you an array, you can quickly give me lower bound and upper bound, right? Yes, great. So see why I told you this thing, because it was not in the in the slides. But while I was trying to solve problems, I have seen a lot of time we are trying to calculate lower bound and upper bound. Then I thought I think I should first explain lower bound and upper bound to people to you guys, because I also understood first lower bound and upper bound, that how we are doing it, right? So let's see. Let's think about the code. Okay. But yeah, let me see first. Let me first see my code, because I have taken like mid first or target, because I told you, right? Binary search code can be written based on your mid element or target, which one you are considering. So that's why I'm seeing my code first, so I can understand which element I have taken to increase left or right. Because see why I'm saying this, because if you are considering AI is greater than target, then I think left and right could go at different side. But if you are taking target as a greater than AI, so the condition could be different. I think these things are a little bit confusing. So let me go to the code and explain it from there. Okay. Okay. So see, so in my code, I think I am taking target as a less than AK. Okay, which is okay element. Okay, great. And for the upper bound, I am taking yeah, target as a greater than T. Okay, let's see. Now let's come back to slides so we can understand. Let's first try to understand the lower bound code. Okay, let's add a new page and let's take one array quickly. Like I think we can take the same array which you were taking in examples. Okay, can we see the slides? 1 minute, guys. Yeah. Okay, we can't. If we okay, we can see. So 2, 4, 6, 6, 8, 10. Yeah, let's take that one. So 2, 4, 6, 6, 8, 10. Okay. So see, our lower would be 0. Lower means left side. Left would be 0. Right. We will take the whole array length. Like that would be 1, 2, 3, 4, 5, 6. Okay. So this would be 6. Correct. Now, and our condition would be left less than right. That would be our main condition. Correct. The till left is less than right, like continuously go into that loop. Okay. Let's see. So now, first we'll calculate the mid, right? So mid would be like 6 plus 0 divided by 2, which will be 3. Correct. So now we'll see, and now let's see our target for which we are trying to look for, like the bound. I think I can take 4. Let's take about the 4. I think the what would be the lower bound and upper bound for 4? I wish you guys can speak also. I have to see in the chat now. Okay, so 1 comma 2. Okay, so some people are saying 1 comma 2, 1 comma 2. Okay, let's see. For the lower bound for be 4, yeah, lower bound would be first and the upper bound would be 2. So we are looking for lower bound, correct? We are looking for lower bound. So what would be the condition? What we need to do? We will now, let's see, our mid is 3. So which means this one, correct? No, no, 1 minute. 0, 1, 2, 3, 4, 5. These are indexes. Correct. So our mid is 3. Sorry, we will take this one. That's why I written the indexes there. Yeah. So this would be the element which we will compare. So let's see what I'm saying. If A of mid is greater than target, is greater than target. That's the condition I'm taking. See here. That's the condition I'm taking, right? Yeah. That's the condition. So that's the condition I'm taking here. 1 minute. See, what condition I'm taking? I'm taking if my A of mid is less than target, sorry, is less than target, then what we need to do? You need to tell me. If my mid element, which is 3, like right now 6, sorry, A of 3 would be 6, which is less than target. What I need to do now? If my mid is less than target, what I need to do? I need to go to left side. I need to go to left side, right, guys? Let me see in the chat. Yeah, no, 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 not go to right. See, that's what that's why these conditions are very confusing. That's why you need to see it here with the array and then decide which side you have to go. So I am putting the condition if my A of mid is less than target, it means my target is greater, right? Oh, sorry, see, I'm also confused here. So see, A of mid is less than target. If my target is lesser, I need to go to left side. I need to go to left side. So you can see in this condition, my target is 4 and my mid is 6, right? It means A of mid is greater and target is 4. So I need to go which side? I need to go to left side only, right? So in this condition, this would be false. This will not go, this will go into the else condition. And what I need to do here, right is equal to mid. Right is equal to mid and left is equal to mid plus 1. Because this element we have already traversed. This element we have already traversed. So we need to go to left side now. So that's why, see guys, this is the condition which we need to, like this is the condition which we need to try, or you do not need to remember. I'm telling it again. You do not need to remember like this. You can try, you can create condition according to you, according to whatever you are thinking right now. You can make A of mid also greater than target, right? But yeah, you just need to think which side you have to go. Correct. So here what I'm trying to do, because I have to go to, let's see, whatever target I'm looking, see in the lower bound scenario, okay, let's think it another way also. In the lower bound scenario, what exactly we are trying to look for? We are trying to look for like the first occurrence of that element, the first occurrence of that element, or might be the might be the lesser position of that. Because if we talk about 3, if we talk about 3, so what would be the position for 3? What would be the position for 3? Position would be 3 for this. So we need to somehow need to go for lesser than that element, lesser than the target. Somehow we need to go to the lesser than target. So that would be the the first position here. That would be a 0 position actually. That's why at that position we'll do left is equal to mid plus 1. See, very okay, guys. Let me explain it again to you guys. I think this was a little bit confusing from my side only. Let me explain it again to you guys. 1 minute. See, let's see this array from the perspective of lower bound. In the case of lower bound, what we exactly are looking? If we what exactly we are looking here? We are looking for the lower bound. And what is lower bound? The minimum position for that element, right? The minimum position for that element. So what we will do here, we will write a condition in a way we should be less than our target. We should be less than our target. So once we will reach to less than our target, we will do simply mid plus 1. So see, if our target is if 4, if we reach to 0, we'll simply do mid plus 1 and we will simply return left. We'll simply return left. Correct. We'll simply return left. See, somehow this mid is given, see, this mid is giving us random indexes, right? This mid is giving us random indexes, but somehow we need to go to that index which is less than our target. Why? Because once we reach to less than our target, we just need to increase one mid and we will get the lower bound. See, in the case of 4, if we somehow reach to 2, we can just simply increase mid plus 1 and we will get our target. That's what we need to do. Now we understood or not? Let me know you understood this part or not. That's what I think. This is a good way to understand this logic. See, talking about the lower bound, it means we need to go to the minimum position. So whatever target we are looking, somehow if we reach to the lesser than that, so we just need to increase mid plus 1. That would be our element. In the case of 3 also, in the case of 3, let's see, for the 3, less than 3, whatever element is less than 3, it is 2. We just need to left is equal to mid plus 1. We will get the lower bound for that. Same goes for 6. Let's take the 6. Somehow if we get lesser than target, which would be the 4 in this case, right? This with this 4. So somehow we just need to do left is equal to mid plus 1. Same goes for 10. If somebody is looking for 10, we just need to reach lesser than that. So that would be the 8. If we reach this index, we just need to do plus 1. That's what, guys, I am doing. Now I think this would be, yeah, I think you guys have understood. Let me now clear it and then write the logic in right way. Yeah. Okay, let me see if anyone not understand. I will explain it again. Everyone got it? I think, yeah, the last one which we talked, I think that was easy to understand. Correct? So see, yeah. So what we said, for finding out a target, for lower bound, somehow if we reach to that element which is lesser than our target, it means we need to write a of mid is equal to lesser than our target. If we reach this condition, we just need to do left is equal to mid plus 1. We just need to do left is equal to mid plus 1, right? Otherwise, else हमें क्या करना है? We have to reduce our right is equal to mid. Why we are doing mid, not mid minus 1? Because might be where right could be in the this place and this could be the lesser element. That's why we are not doing right is equal to mid minus 1. Are we good with this code now, guys? Are we good with that? Yeah, Nishan, please tell. What's the doubt here? I know these things are little bit difficult to explain also. So that's why trying to different examples. Yeah. If mid is RIF is equal to mid, repeat. Right is equal to mid. Okay, right is equal to mid. See, why? See, right is equal to mid is definitely needed. Why? Because if our target is if that element is not less than target, it means this element is greater than our target. It means talking about 4, and somehow if we reach 8, if we are looking for 4 and somehow our mid element a of mid has given us 4, it means we need to go to right side. Sorry, if we need to go to left side. It means we have to reduce our right. हम लेफ्ट साइड कैसे जाएंगे? जब हम राइट को रिड्यूस करेंगे. When we reduce our right, then only we will go to the left side. Otherwise, right will always be at this place, right? Always right will be at the end of this. So that's why we are reducing our right to mid. So whatever position now, if somehow we get 8, we'll make this right, because this could be our greater element, right? This could be our element. See, in the case of 10, if we are looking for lower bound for 10, we have to reach to this index only. Then only we can do left is equal to mid plus 1. So that's why we are not subtracting anything in the right. Right is equal to mid minus 1. Correct? That's why wherever mid is coming, we are directly putting our right there. We are not leaving any element. Okay? That's why we are not changing the right is equal to mid minus 1. Yeah, explained it, right? Yeah, sure, Nishan. Nishan wants to speak, so let's see. Yeah, Nishan, please speak.
Am I audible?
Yes, you are.
सर एक्चुअली मेरा क्वेश्चन था सर, जैसे अपन ने उसका टारगेट फाइंड किया, तो सर टारगेट फाइंड करने में जैसे अपन ने स्टार्टिंग इंडेक्स अपन ने 0 लिया, राइट? तो सर बट एंडिंग में अपन ने उसकी लेंथ क्यों ली? मतलब लेंथ -1 होना चाहिए था ना बेसिकली। लाइक आपने n इक्वल्स टू लाइक 6 लिया, बट वो तो लाइक n-1 होना चाहिए था ना।
नहीं, हमने 6 इसलिए लिया क्योंकि इस कंडीशन में जैसे कि हमारे पास 5 है, जैसे कि हम अगर जैसे क्या बोलते हैं कि लास्ट एलिमेंट के लिए अगर कोई पूछता लोअर बाउंड, जैसे 11 के लिए कोई लोअर बाउंड पूछता 11 के लिए, तो उस कंडीशन में हमें क्या करते कि हमें 10 के ऊपर जाना पड़ता, राइट? हमारे लिए उसके लोअर बाउंड क्या होता? 6 होता, राइट? इसलिए हमने सारे के सारे एलिमेंट्स के लिए लिया है, क्योंकि हम कोई भी लेंथ को नहीं छोड़ना चाहते, लास्ट एलिमेंट तक को नहीं छोड़ना चाहते। तो हमारा क्या होगा कि राइट वहां पर 5 आएगा और हम लेफ्ट से मिड +1 कर देंगे। जैसे हमारा टारगेट, जैसे 11 क्या है कि 11 के लिए हमारे लिए कंडीशन क्या आएगी? ए ऑफ मिड होगा 10 और यहाँ पे टारगेट होगा 11, ये कंडीशन ट्रू हो जाएगी, तो हम उसमें लेफ्ट को मिड +1 कर देंगे, तो 5 + 1 6 हो जाएगा। इसलिए हमने r 6 लिया, हम कोई भी एलिमेंट छोड़ना नहीं चाहते इसमें, करेक्ट?
ओके सर, बस लाइक वही डाउट था।
होगा
थैंक यू।
ये ऐसी चीज है एक्चुअली, इसमें यू कैन लाइक change according, that's why I'm saying you can play according to you, according to your conditions only. There would be some of the edge cases, then you will correct the r there, sometime you will take r-1. That's what guys.
Okay sir, thank you.
Yeah, thanks. So let's see the implementation is now very easy because you have understood that part. So you can see we have taken the length here, right is equal to n, we have taken the left 0, right? See, I also written this thing, bring your left index just lower than target. See, when I was also trying to understand, I written this thing, bring your left index just lower than target and then increase left by 1 to get lower bound. See, that's what, if element found, then well and good, and that index. Otherwise, if not found, then left +1 would be the lower bound for that new element. That's true. That's what I did. See, we figured it out. Mid element. Then I put, if mid element is less than target, reach till that element which is less than our target, and then once you reach it, left is equal to k+1. Otherwise, right is equal to k. Try to reduce your array, and then at the end return the left. Okay, guys, are we good with the left bound code? Right, let me also run it so you guys can also see the answers, right? So we have taken this example, right? 2 6 7 8 9 10 10 12 13. Okay, let's try for 6. Okay, node bound.js. So see, for the index would be 1, right? Let me look for 10. So can anyone tell me the index for 10? Can anyone tell me the index for 10? 0, 1, 2, 3, 4, 5. Right? So this should be 5. Right? Let's look for any new element, which could be like 1. Let's look for 1. What could be the index our code is giving? See, 0. That would be the first lower bound index. Let's look for 14. What is the index it is giving? See, the 9. This would be the length of array. 1, 2, 3, 4, 5, 6, 7, 8, 9. Correct? That would be the length of array. अब जो भी बड़ा होगा 13 से, सबके लिए 9 ही होगा, right? So anything we are missing? I think we are missing 5. Let's see, 5. The first index. Correct? क्या? क्योंकि देखो, हम 5 के लिए क्या किया हमने? What we did for 5? We just came to the lesser than that 5. That would be the 2. जैसे हम लेसर पे आए, हमने लेफ्ट इज इक्वल टू मिड +1 कर दिया. हम राइट, why we are doing right is equal to mid? Because we are not leaving any element from the right. See, rather than doing right is equal to mid, the other thing is right is equal to mid -1. Other thing is right is equal to mid -1. Otherwise right is equal to mid. जहां पे भी हम मिड हमें छोड़ रहा है, हम वहीं से हम राइट को ले रहे हैं, हम उस एलिमेंट को छोड़ नहीं रहे हैं. We are not leaving that element. Other than right is equal to mid, what is the other thing? It's the right is equal to mid -1. It means we are leaving that mid -1, but we are not leaving any element here. We are just simply doing right is equal to mid. Okay. If 0, Niranjan is saying if 0, yeah, 0 is also there, right? We have searched for 0, right? See, 0 is lesser than 2, so always it will be 1, 0th position. Always, see, because it is lesser than 2. That's why it's 0 again. You can look for 1, 0, whatever lesser than 2. Whatever lesser than 2 always will be the 0th index. Like 1, you have looked for 1, right? Use position. Okay, so that was for lower bound, guys. Let's look into the upper bound. I think the same thing is for upper bound also. This time, rather than looking for, yeah, let's move into this one. Yeah, this one. Now let's take the upper bound. Same example: 2, 4, 6, 6, 8, 10. That was our example, like 2, 4, 6, 6, 2, 4, 6, 6, 8, 10. अब देखो अपर बाउंड के लिए क्या है, let's take a 6 only. हम positive case we will take, right? So the positive case, target is 6. So upper bound would be, so first tell me what will be the upper bound for this. Let me write the indexes also, then we'll understand. What would be the upper bound for 6? Everyone, 4. Yes, because we have also already understood what is the, how can we calculate the upper bound. Okay, so see, same thinking we will apply, which we have applied for lower bound. We'll apply the same thinking. अब हमें क्या, what is the same thinking? We have to somehow reach to the element which is greater than our target, because that's what we need to do. Upper bound is greater position, right? So somehow we have to reach that place where our element is greater than our target. So that's what we are doing in the code. See, as we reach our the greater position right now. See, and see, right now we are talking about greater position. It means we have to go to the right side, right? See, whenever we are talking about the greater position, and it's the increasing sorted array, it is the increasing sorted array. So that's why if we are looking for the greater position, so we have to now this time think about the right, because we have to move into the right side. So this time in the upper bound, our answer will come with the right index, not with the left index. When we are talking about the less than element, lower bound, at that time we have to go to the left side. That's why we were taking the left. But this time we have to talk about the greater element. For greater element, we always have to go to the right side, because it's the increasing sorted array. Correct? So that's why, so our condition would be, we have to reach to that element which is greater than our target. No, not this condition, which is greater than our target. We have to reach to that element which is greater than our target. As we reach greater than target, we have to stop our right at that position only. We have to stop our right at that position. Otherwise, we have to simply do left is equal to mid plus 1. Otherwise, simply increase our left. Or if you do not want to increase plus 1, this, I think this could be plus 1, like we have to put plus 1 or not. I think this could only be decided with this condition, which we will put here, left less than right. It will be based on this condition. We have to put our left or right, left equal mid plus 1. So guys, let's take this example only. So AI is equal to left is equal to 0, right is equal to 6, right? 1, 2, 3, 4, 5, 6. Okay, so let's see A of mid. So mid would be 3, right? 0 plus 6 by divided by 2. Mid would be 3 at first position. So right, see, would be 3 would be 6, right? And our condition is A of mid is greater than target. No, this is not greater than target, right? You can see 6 greater than 6. No, it's a wrong condition, right? Still our right is at 6. Right, you know, right? This right is equal to 6. So what we need to do? We have to go to the left side. Correct? So left is equal to mid plus 1. That's what we did. Left is equal to mid plus 1. So now our left will become 4. Or right is still 6. Right is still 6. Correct? So now what we will do? We will again calculate the mid. 4 plus 6 divided by 2. This will be 5. Mid is equal to 5. Let's look for 5, which is 10. Correct? Which is 10. So what we will see? A of mid, is A of mid greater than target? Yes, it is. It is greater than target, right? So now right will become 5. Now right will become 5. And left is still 4 in earlier case. Correct? Still our condition is not true. Left less than right. So now we will again go 4 plus 5 divided by 2. 9 divided by 2, 9 divided by 2, this will be 4. Now our mid will become 4, correct? And now again we will check, A of mid greater than target? Yes, A of mid is still greater than target because 8. So now our right will become 4 and left is also 4. Now our condition will fail, 4 less than 4, and now we will return right, which is the fourth index. So that's what, guys, it's happening here. Right is equal to mid and left is equal to mid plus 1. And you can see the similar thing, whatever we talked there, that's what we are happening here. So see, for lower bound and upper bound, once you are writing this code, you just need to remember these two conditions: A of mid greater than T, or A of mid A of mid greater than target, or A of mid lesser than target. See, if you will see the internet code, guys, if you will see the internet code, lot of different variations are there. I was also very confused. Sometimes they are doing right is equal to mid minus 1. Sometimes they are doing right is equal to mid. Sometimes they are taking 0 to n minus 1. Sometimes they are taking left less than greater than, like in the while condition, they are taking left like less than equal to right. So there are many variation for that. So, but I will tell you, do not like ignore all those variations. Try to think according to your mind, right? This is the code which I have implemented. So what I did, I just taken one array, and I think I just simply put two logic there. One is, if we are talking about the lower bound, somehow we need to move to left side. Somehow we need to move to left side. So that's why, and the second thing which I put, which is my target for the lower bound, my target should be greater than or should be lesser than the mid element. My target, the array element should be lesser than target. For lower bound, I only taken two things, guys. First thing, my element from the array should be lesser than target. Should be lesser than target. I'm telling right this time. My array element should be lesser than target. So as we reach to this mid element, I will do just left is equal to mid plus 1. That was two things. That's the first thing. And second thing, because I'm talking about the lower bound, I need to go to the left side. That was two things. Yeah. Same goes for upper bound. The first thing, I have to find an element in array which is greater than my target, which is greater than my target. In lower bound, lesser than my target. In lower bound, lesser than my target. In upper bound, greater than my target. And then it's a right, because we are looking for greater, it means we have to go to right side. I only remember these two things. After that, guys, after that I didn't remember anything. I need to do mid minus 1, I need to do that. I didn't remember these things. What condition I need to put in the while, automatically that those conditions could be fulfilled. Okay, guys, so that's what I will also say to you. Just remember these two things while implementing upper bound and lower bound. And once you will do that, very quickly you will like in interview, you will just take some minutes to figure it out. You have to do left is equal to mid plus 1, or what condition you need to put in the while. And I think always go with the easy one. Take the 0 to 6 and always take left less than right. You can see in both scenarios. In both scenarios, I have not changed anything. I have taken n is equal to whole length, left is equal to 0. I always taken left less than right. I always taken mat.floor left plus right divided by 2 in both scenarios, you can see. And just I have work on these conditions. Just work on these conditions. Okay, guys. That's how we can simply make all the logic in easy way. Otherwise, you will get a lot of variations in the internet for the same code. Okay, so now let's see the questions. So Hari is saying, why here, why left instead of less than is equal to? See Hari, that's what I'm saying. We can see less than equal to, we can also do that. But we have to check, well, like if we are missing any of the edge cases. If we are missing any of the edge cases, then we can go for left less than equal to also. But I think as we are increasing our left or right, I think we are not missing any of the edge cases. I have seen in both scenarios. You can see, I have already seen, see, already we are taking our right greater, so we do not need to make left equal. See, left equal, what is the meaning of left less than equal? Means जब left और right बराबर हो जाए तब भी loop में जाओ, right? That's what the meaning of less than equal to. When when left and right both are equal, you have to enter into the loop. But we have already taken the length as 6. It means we are already saying you have to iterate one more time. Less than equal to 0 to n minus scenario, where we are saying we have only 5 element. You have to now figure. You have to now move in between that, between them. But we have already removed there. We are already given one more element, one more place to iterate. That's why we are looking left less than right. Okay, Ariran? Hope I answered your question. This answer a little bit confusing first time. Can you again repeat upper bound? It's like the question we did in the previous session, finding the yes, Vishal, that's right. That's the same. With the help of these, we solve these type of problems. Find the occurrence from the right side. Find the occurrence of any element from the right side. Find the occurrence of any element from the first side, right? Or same questions give the maximum number after x, after any number give the maximum number. Like they will give the 5, give me the maximum number after 5. In these type of problems you can simply use this lower bound and upper bound. Okay, okay, so Nishant was saying, Nishant, is it still confusing to you, or it was earlier you asked? Still you have doubt on that? A little bit confusing. Yeah, so sure, no problem. See, for upper bound, see, the two things you need to remember for upper bound, because in the upper bound the condition was we have to find out the maximum position. Maximum position. So what the first logic which we think of, that somehow if we find an element which is greater than our target, which is greater than our target, so that's why that would be the only position where our where the upper bound would be. Like if we talk about 6, so the greater element of that would be 8. That means that would be the upper bound for that. If we talk about 4, so the greater element of 4, that would be 6. And this means 2 would be the index for that. That's what only my thinking while thinking about the upper bound. So I ran this much condition there. In the else part, अब देखो हमें right side जाना है. We have, because we are talking about the greater element, and greater element always goes on the right side because it's a sorted incremented array. So that's why we have to somehow play with right is equal to mid. So if right is equal to mid in else part, it means we have to increase our left side because we have to go to the right side. So it means if somehow if we didn't find any element which is greater than our target, we have to move to left side. If somehow we are not finding any element which is not greater than our target, it means we have to go to the for finding out the greater element, which side we will go? We will only go to the right side, correct? Because this is sorted array. हमेशा जो greater element होगा, जो maximum element होगा, वो right side पे ही होगा. So that's why we have to go to the right side. That's why we are only increasing left is equal to mid plus 1. But in the previous scenarios, we were trying to find out the lower element. So that's why we are trying to go for the lower side. Okay. Yes, I think yes, that's right, Nikhil. You can these type of things. So see, all of the problems which I'm going to explain it today, I will just try to explain them with the logics only, like this with the dashboard, and then I will show you the code. But until you guys want practice it, once you will practice it, you will get more ideas, right? Which will help you to design solution in your way rather than according to my way. You just take from my side, you just take understanding. See, I am just telling you one way to solve problem. I am just showing you one way to solve problem. There could be many ways to solve problem, same problem. The upper bound and lower bound could be solved with many ways. I just showed you one way to solve problem, but there are many ways to solve problems. You guys can figure it out the better way also, but you have to start from somewhere. That's the start I am giving to you. Okay, guys. Let's see. Sir, whenever you push code in GitHub, please make in branches so that we can find that branch for that. Sure. Sure, I will do that. I haven't pushed any code for today, so I will create a branch. Okay, so that was about the lower bound and upper bound. So let's take, I think I'm thinking to take, okay, so sir can explain the upper bound again. Sure, Deepak. So see, for the upper bound, I told them that we need to think about two scenarios. Once, somehow we find an element in the array which is greater than our target. अगर हम वहां पहुंच गए उस एलिमेंट के पास, so it means that is the index where the greater element index is the one which is our upper bound. Okay, that's the first thing which we need to remember. And the second thing which we need to remember, because we have to look for greater element, and in the sorted array, incremented sorted array, only the greater element will be on the right side. So that's why we have to somehow play with right side, and our answer will also be written with the right index. So that's why in the code you can see, let me share my screen again. Yeah, in my code you can see, if somehow if my target is greater than if my mid is greater than target, I was just simply shifting my right to that side, right to that element. And if somehow if the a of mid is not greater than target, I am just trying to move to right side. That's why left is equal to mid plus 1. Left is equal to mid plus, because I am trying to move to right side. And when that element is greater than target, I am trying to bring my right to that. क्योंकि इससे अब नीचे नहीं जाना है, इससे अब लेफ्ट साइड नहीं जाना है. दैट्स व्हाई राइट इज इक्वल टू मिड. जैसे हम ग्रेटर एलिमेंट में पहुंच रहे हैं, उससे अब नीचे नहीं जाना है. सो दैट्स व्हाई राइट इज इक्वल टू मिड, और हमें लेफ्ट को अपने राइट के पास लाना है. सो दैट्स व्हाट आई एम डूइंग इन द कोड. ओके दीपक, अंडरस्टूड दीपक, और एनी डाउट यू हैव? Okay, great. Okay, so let's see the first question. I think if talk about the questions, so I think the easy one would be the second one, square using binary search, or not a triangle. I think those two questions were easy only. After that, let's start with pair of topics first. Okay, let's take one tough question first. Okay, I think that this is not that much tough, but yeah, let's see. So they are saying, no, I think start with tough, then we'll go for one easy one. Okay. Oh, okay, let me share my screen. So, and I open the slides there, so we can. Yeah. So see, let's take this question. So they are saying we pair of topics, right? So the question is, they are providing one array to us, that they the aim is to discover the number of pair of indices in two integers array of equal size, such that ai plus aj is greater than vi plus vj and I is less than j. The basic technique is to verify, okay, of all possible the concept. Okay, that's fine. Let's look for the example now. So they are not giving an example. What happened? Okay, they have not given an example. Okay, no problem. Let's see what they are what they're saying to us. Let's go to the notes. Okay, let's open a new page. So they are saying, guys, we'll just what is happening? Why I'm coming to Teams? Yeah. Okay. Yeah. Great. Okay. I'm going to the private window. We don't want. Yeah, we have to come here. So they are saying, guys, we have two arrays, right? AI and B. These are the two integers array which has equal size, and they want us to give us a pair where the condition should be, for those pairs, condition should be AI plus AJ greater than BI plus BJ. So let's first write this condition here. So the condition is AI, little bit math, I know. But let's see. AI plus AJ greater than B of I plus B of J. ठीक है, B of I plus BJ. और फिर उन्होंने बोला एंड I लेस देन J. हमारा भाई I भी लेस देन J होना चाहिए. ऐसा नहीं कि आप मतलब ऐसा नहीं कि आप J, like you are picking any element from the Jth position and then that Jth position is like, see why they are giving this. So they are giving like this. If we take an example like 2, comma 4, comma 6, right? Now they are saying we have to take that pair, like in this, take the pair 2, comma 6. So this pair should be like this, not like this 6, comma 2. हमेशा जो 6 का इंडेक्स देखो 0 1 2, 6 index is 2, right? So they are saying always our pair should be that one, like where the index is in, like the I index is lesser and j index is 2. So like pair should be 2, comma 6, like the like in increasing order, not in like this opposite one 6, comma 2. That's what they are saying. The pair should be like the we should be like going into the right side, not into the left side. Okay guys, so like somehow the pair should, like this condition, the pair, whatever pair we will get, the I and jth value should be like that, where I should be lesser than j. It's not like I should be greater and for the same element j should be lesser. Like ai could not be 2 or aj could not be 1. This pair they will not accept. This pair, if somehow we are getting 6, comma 2 or 6, comma 4, they will not accept for this condition. They are saying like the I should be 1 and j should be 2, like 4, comma 6. This pair they can accept. Okay, so guys, I have not explained this thing. I just explained this line to you, I less than j. Let me, so I want you guys also to be like, tell me in the middle, you guys are able to understand that or not. Did you guys understood this part, I less than j? Anyone? Okay, so Niranjan has not got it, so let me just quickly explain it. See Niranjan, what they are saying, I less than j meaning हमें इंडेक्स लेफ्ट से राइट की तरफ लेने हैं. हमें जो भी पेयर बनाना है, we have to take that pair where the second element of that pair, because see they are looking for one pair, right? In the question they are looking for one pair I comma j, pair of indices. Pair of indices means pair of indexes. So they are looking for indexes, and they are saying indexes should be, the I index should be less than j. It should not be greater. So like in this scenario, if we take the pair comma 4, comma 6 in this, or 6, comma 4, so you tell me which one they will accept. 4, comma 6 and 6, comma 4, which one they will accept? This one or this one? Like A or B, which one they will accept? Tell me in the chat. Which one they will accept, A or B? 4. Yeah, that's what guys, that's what they are meaning. So somehow we need to, जब भी हम चेक करेंगे, हम लेफ्ट से राइट की तरफ चेक करेंगे. Okay, that's why this line is very important, because I will show you why this line is very important. Okay, that's why I spent that much time to test and just tell you guys this thing. Okay, so now, yeah, so now okay, let me erase this line also. So now let's simplify this equation. Now let's simplify this equation. So now how we will simplify? Somehow we will bring these elements here. So ai plus aj, what is happening? Yeah, minus v of I minus b of j and greater than 0. करेक्ट. अब हम क्या करेंगे, a of I माइनस b of I एक जगह रख लेंगे, प्लस a of j माइनस b of j एक जगह रख लेंगे. ओके गाइस, दैट्स व्हाट विल डू. हमने क्या किया, दो एरो को एक साथ बना लिया. हम इसी इक्वेशन को ऐसे भी लिख सकते हैं, राइट? एम आई राइट? वी कैन राइट दिस इक्वेशन लाइक दिस, राइट? एवरीवन करेक्ट? ये नहीं ठीक है, व्हाट इज दैट मीन? ये भी ठीक है. Oh, okay, ये भी ठीक है. Yeah, so we just write the equation in this way. So now see why we are doing this. So let's take a small array. A is equal to, let me take if any example which we are taking in while understanding these things. So what is pair sum, right? Or pairs? Yeah, I will take that example only, right? Yeah, 4 8 6 2. Now that example, because I will take this example to understand you also, and then we will take this example in coding also. 48262, 48262, this is A, और B हम लोग ले सकते हैं 45413. We'll take anything, but just randomly we are taking this one. 45413. See, why we are doing this thing? Because now we can create, rather than, see, because at the end we have to go with the binary search, right? So in binary search, it would be better if somehow we can convert these two arrays in one array only. So that's what we'll do. We will create AI minus VI and we'll write it as a DI, a new array, and AJ minus VJ will also become DJ. D option J, and this should be greater than 0. करेक्ट. सो सी ये क्या हुआ, ये हमने नया एक एरे बनाया जिसमें हमने ए और बी को घटा दिया. तो 4 minus 4 0, 8 minus 5 3, 2 4 minus 2, 6 1 5, 2 3 minus 1. That's what we did. Why we did? According to our equation. According to our equation, AI minus VI plus AJ minus VJ. If we will reduce, see, according to, this is simple math. AI minus VI we will get DI. Correct? If AJ minus VJ will get reduced, we will get DJ. We are still working according to our equation, and that's what we did it here also. That's what we created a D. Why we did, we will tell it later. But till now, we have not created any new thing. We have just following our equation. We have created the new array with the ith index. That's what we did. Correct? Let me know. I know this could be confusing for some people, but yeah, let's see. Yeah, I'm sure there would be some doubt for this. Let me know if you guys any doubt in that. So see guys, let me repeat it. First, what I did, I taken the main equation AI plus AJ, BI plus VJ, correct? Then what I did, I just like put all the variables at one side, which is BI minus VJ greater than 0, AI minus VI, AJ minus VJ greater than 0. I just move the variables here and there in the equation. After that, I got something like this: AI minus VI, AJ minus VJ, correct, which are greater than 0. So now what I did, I just converted this AI minus VI in some other equation, which is DI, or AJ minus VJ is equal to DJ, right? So that's what I have converted this into a new array, which is 0, 3, minus 2, 5, minus 1. This is also DI, this is also DJ, whatever you want to consider, because this is a one single array. This is one single array which is having DI also, which is having DJ also. Both elements are here. Correct? Now, in this array, we have to find out, because see, this is only DI, this is only DJ only. All the ith elements are also there, all the jth elements are also there. So somehow we need to find it out, like if we take 0 plus 0, this should be greater than 0. Correct? See, in this equation only, if you want to prove this equation here, so what will be the pair for us? Let's take the 0 first. So 0, see, now the first condition, I greater than j. Guys, I'm just trying to explain something else. Let's not think about anything else. Whatever I'm saying right now, let's try to create, we got this array, and then now let's try to prove this, like according to this equation, let's try to get the pairs. So let's see, this is the 0th index, 1, 2, 3, 4. Okay, so now we have to move somehow left to right. हमें वो पेयर्स चाहिए जो लेफ्ट टू राइट में इस इक्वेशन को सही करें. अब देखो, हम सबसे पहले आई हमारा, अब देखो आई हमारा 0 हो सकता है और जे हमारा 1 हो सकता है. अब देखो D0 क्या है, D0 0 है और DJ क्या है 1. So 0 plus 3 greater than 0. Yes. So once first pair could be 0, 3. Right? Now let's see. अब हम क्या करते हैं, अब इसी 0 को यहीं रखते हैं, अब इसको ले चलते हैं 0 को. अब हम क्या करेंगे, दिस इज फर्स्ट पेयर with this, right? Now the second pair, let's remove this thing. I'm just trying to explain this equation again to you guys. Now let's see, I is equal to 0 still, and now j is equal to 2. अब हम क्या कर रहे हैं, इसको ले रहे हैं. ठीक है, अब देखो 0 minus 2 greater than 0. No, this could not be our pair. 0, 2, no, this could not be pair. Now let's take 0, 5. Yes, this could be one pair, right? 0, 5 could be one pair. 0, -1. This could not be our pair, right? Now let's take 3. 3 - 2. Yes, this could be one pair. 3 - 2. अब हमने 3, 0 क्यों नहीं लिया? You guys tell me why I have not taken 3, 0. If you are able to understand, tell me why I have not taken 0, 3, 0. Yes, because I less than j. Right, guys? Because I less than j, that's why I have not taken 3, 0. Okay. Now let's see. Let's talk about -2. Let's talk about the negative one. So -2. -2 could be only added to 5. So -2 plus 5 is 3. Yes, -2, 5 could be one pair. Now let's take -2, -1. -2, -1. This could not be pair. अब -2 और 3 ये pair नहीं हो सकता according to I greater than j condition. Correct? Am I right, guys? Am I right, guys? Yes. Okay. So now I think with this much theory, with this much logic, I think we have understood the question and we also have understood how to solve it. Correct? Somehow we have seen it. Like, see, somehow first we will get one array. We will simply, I think we have to just subtract each element array because these are same length. We can simply subtract it. 8 - 5, 2 - 4, 6 - 1, 2 - 3, and we'll get a new array. Correct? अब उस new array में हमें simply I से j की तरफ loop चलाना है. We have to simply loop I to j, take first element, and j start होगा I plus 1 से. अगर हमें bootstrap like brute force करना होता, if it's a linear search, so it will be I is equal to 0 to n, right? And then j loop will be I plus 1 to n, और हम addition करते चले जाते हैं, right? We just do 0 plus 3, और अगर वो greater than 0 है, we'll say yes, this is a pair, otherwise no. Correct? Correct, guys? हम solve कर चुके होते इसको. This is the brute force way. Tell me, did you guys understood the brute force way with the two loops? Are we able to solve this problem or not? Everyone, with the brute force, are we able to understand this problem? Okay, tell me if like till now whatever we have explained is anything where you guys faced any problem. I think you should not be, because I think we have explained it I think we have explained this logic also nicely. So did you guys face any problem till now? Let me know so I can explain the things again. Otherwise, there is one more step to go further, which I have to explain. But let me know till now if you guys face any problem. If we do not have any concern with the brute force, I think we could simply solve this problem now with just two loops, I and j. Okay, so now let's see Likit has one out. Yes, but why to create a new array di? Because we can directly do ai plus aj greater than bi plus bj. Yeah, we can do that. But yes, I think Likit is also right. Why we did that? Because we can do two loops there also, right? We can do simply two loops I and j there, and then we can go through that. Yes, that's right. We can do that there. But see, why we are doing it here? Because we have to improve our solution. And for improving our solution, we will go for binary search. Correct? In binary search, we need one array only. In that one, I will show you in one array how quickly we can solve this problem with the binary search with less time complexity. And that's what I'm going to discuss it after this. Okay, but if we ignore that part, that if we want to go with two loops, then I think other than that, you can see we have simply solved our equation and converted these two equation in one array or in one function, that is di or dj. That's what we did, right? We have converted two array into one array. Are we good with that? No problem, but di and dj was a very twisted thing. How will we do dj things? Are confused in that. How will we do dj things in confused with that? Okay, so see, di and dj. Who was that? Hariharan. So di and dj, these are like I and j are only difference, but the array is same. I and J are different, but array is same, Hariharan. Okay, so we are traversing in the same array for I and J, but it should be I should be greater than J. Those pairs only we will take. And so for taking the pairs, two conditions: I should be greater than J, or Di plus Dj addition. Like if we add them, some of them should be greater than 0. So in the same array, we are iterating it. So you can see I is equal to 0, J is equal to 1. Why we are not taking 0, J is equal to 0? Because our condition is I greater than J. That's why. So that's why Di and Dj are not different things. They are same array, but we will iterate in different way. Same array. We will iterate the same array in different way. Okay. Okay. So now, guys, let's think about a better way to solve this Di plus Dj scenario. Let's take another page and let's copy the same thing there. Di plus Dj greater than 0. Or we'll take this 0, comma 3. Yeah, this array also 0, comma 3, comma minus 2. What was the 5, comma minus 1? 5, comma minus 1. Okay, and our condition was I greater than J. Ab dekho, we will solve this problem with a binary search. So the first condition for binary search is to sort this array. So first we'll sort this array. Minus 2, minus 1, 0, 3, and 5. Ab dekho guys, once we sorted it out, can you see how easy it could happen? How easy we have made this array. देखो हमें क्या चाहिए था, di plus dj greater than 0. अब देखो जो भी इवन पोजीशन होंगी और definitely those even position would be at the right side, definitely, because this is a sorted array. और sorted array में हमेशा right side पे greater चीजें होती हैं, right? So that's mean automatically all the even positions, wherever those even positions are there, if you will add them into the right side, they will always be always be pairs. These elements will always be pairs. Like if you take about the 3, 5, this will always be pair, right? If you take about 0, 3, both are even. 3, 0, 5, 5. So these are always the pair. 3, 5, 0, 3, 0, 5. So that's why if we are getting any of the positive element, if we are getting anywhere any positive element, we do not need to do anything. The concern is here only for negative elements, because हमें उन नेगेटिव एलिमेंट्स के लिए कोई ऐसा एलिमेंट्स चाहिए जो उन्हें पॉजिटिव कर सके. We need an element for negative element which could make them positive to make this condition true, because our condition is di plus dj greater than 0. It means we need an element for the negative index which could make them positive. So that element would be, like for the minus 2, that element would be 3 and 5. Minus 2, 3, minus 2, 5. These would be the two indexes which could make minus 2, which could make this condition true, and I greater than j condition also true. Sorry, I less than j. This condition also true, because I is 0 here and j is 4 here. This condition is also true. So that's what guys, why we are using the binary search, because for the positive index, we do not need to use anything. We can simply say, like we can take one total variable, how many pairs would be there. We can simply add the, add that if this is the place, we can simply, like for the last index, it could not, because for the last index, it could not add to anyone. This 5 could add to anyone. Okay, you guys tell me. This 5 could be added to anyone on the right side. This 5 could make any of the pair with any of the jth element, because this 5 is the last element. So this 5 will not make any element. So for while we are traversing into the 5, the total would be 0, because this will not make any pair. Correct? Once we will move to 3, so 3 could make pairs with all the remaining elements, because if this 3 is positive, it means according to the binary sorted search, all the right side of element will be positive. If this element is positive, it means all the right side of this element will be positive. It means we can simply take like total array length or whatever the index of this. So like total array length is 1, 2, 3, 4, 5, or whatever the index of this. Index is 4. One like 0, 1, 2, 3, 3. Right? So we can simply write here 2. Right? We can simply write this 2. No, but 2 is also not right because 3 could not make a 2 pairs here. So I think, oh yes, oh yes, why, we are taking the index here, right? We are taking the index here. So for index, see, we are starting from 0 to n minus 1. So we have already reduced the minus 1. So that's why 2 minus 1 is equal to 1. It can only make one pair, right? 3 could only make on the right side one pair, 3, 5. So that's why 3, 2 minus. So the rule would be total is equal to, see, total is equal to n minus index minus 1. N would be the total element. 5, index would be at which position it is. Like for the 5, it would be 4th, n minus 1. So this you can see 0 here. Same goes for 3. Total is equal to n would be 5. Index would be, what is the index here? 3, n minus 1. 5 minus 3 minus 1 minus 4. It would be 1. Same goes for 0 also. Total is equal to 0. So 5 minus what is the index for this? 2 minus 1, right? So it would be 0, 1, 2, right? Yeah, index is correct. 5 minus 3 is would be 2. So you can see 0, 3, 0, 5. 2 pair it could make. But for minus 1, we need to find it out. For minus 1, we cannot say that the right element, like the next element, all next element can make it positive. Like 0 cannot make it positive, right? Right, guys? For minus 1 or minus 2, we cannot say that like the all the right element make it positive. That's why we need to find it out somehow that who can make minus 2 positive. Minus 2 positive. Who can make minus 2 positive? So for that, we'll do the binary search. So for that, we'll do the find search. And how we'll do that? We'll make this as a negative, like minus 2, we'll make this minus 2 minus, like the opposite of this 2. And we'll find it out if we have any index in the, if we have any index or upper bound. We can see simply upper bound. If we have any of the element in the array which has upper bound for 2, upper bound for 2. So we will take that index. So you can see for minus 1, the upper bound would be 3, right? For minus 1, upper bound would be 3. So what would be the index for this? So index would be 4, right? 0, 1, 2, 3. So index would be 3, right? So we can see that. So now we will return this index from here. Like upper bound we will return from here. And then I think we'll simply reduce this 5 minus 3. Simply deduct it like this and 2. I think minus 1 comma 3 and minus 1 comma 5. These two elements could make the two relation, two pairs. So that's what we will do, n minus k. Okay, let me stop it. I think because I have already discussed the solution, let me stop it here. And I think I can discuss this part later, the minus one. Let's first discuss the positive part. And let me see if you guys have any doubt on that. Then we will go into the negative part. I know it's a little bit confusing, guys. I already told you in the starting, but we'll try to understand slowly. Okay. So let me first tell you guys tell me. Sure, after this, we will take the break. So you guys tell me first, in the positive scenario, you guys face any problem? So Vishal, complexity of logic increases only first time when you are trying to understand the problem. First time when you're trying to understand the problem and do that, at that time only you see the complexity. Once you understood the logic, everything looks easy to you. Okay, so confusing. Yeah, I am following that rule. I am already following that rule. I am only taking 3,5. I'm not taking 5,3 because minus 2,3 is invalid. Minus 2, no, I is equal to 0 and j is equal to 4. How this is invalid? J is equal to 3. I is equal to j is equal to 3. This rule is still valid. before sorted, we have already sorted this array, right? So we will apply our logic in the sorted array, right? We'll apply our this logic di plus dj greater than 0, I greater than j in this logic. Okay, Likit? After sorting, we will apply this logic now. Yes, it will change. No problem. No problem with that. See, they are not saying about anywhere that see these indexes di plus dj we can change it anything, right? See, these indexes we can change it anyways because see why we can change it this indexes. Let me also think about it because see the reason for changing this indexes, we are only looking for I and j, right? We are only looking for I and j, correct? And I think I and j if you are looking for, and if you will change this array, still I think see I when I was trying to explain this thing to you, I will trying to take this array to you guys, but internally like it looks like to me that where like let's not talk about here. Let's talk about here in this array, in this example. If we will change the indexes, if we are sorting it, will it create any problem to us? Okay, yeah. By the way, yes. Okay, no. By the way, see, in this array also, if we are taking, see, after sorting also for -2, how many indexes we got? -2 comma 3, how many pairs we got? -2 comma 3 and -2 comma 5, right? And let's see here in this indexes also. Okay, so you are saying, okay, so 3 comma -2 could be the wrong here. Okay, so I will not waste my time more here, but yeah, I will think about it and then I will come back to you. Okay, I think I'm not getting right now the reason that it will not impact. Sure, Likit. So I will just look into that one, and if you guys have any idea, let me know. And that no, actually, I'm not getting the idea right now, but definitely that won't impact here. But why it won't? I'm just thinking about that. That why it won't impact here. Anyone has any ideas, suggestions for this thing? That if we got di plus dj and di and dj is the same array, right? So if we are changing the indexes, will it make any change here? Because we are looking for the pairs. If we talk about here, we are looking for the pairs which are which should be di plus dj greater than 0. Okay, now why we are looking into here? We have converted this into this one, right? Let's give it 2 minute thought. If we didn't get, we'll just move ahead. Okay, and I will think about it and then I will just repeat it here. Okay, let's think two more minutes here. So see what we did. So so we have di plus dj. Okay, we have one array, and somehow we need to find it out that the addition of these internal element should be greater than 0. Okay, and we also need to follow the condition for I less than j. Okay, so hmm, hmm, I think yeah. Okay, sure. I am not getting right now any idea. I won't lie, but yeah, I will think about it and we'll talk about it later. Sure. Okay, somebody is saying anything. Can you show examples for input and output? Can you show input and output? Okay, let's see. So yeah, this is the input, right? 482648544413. Let's see the output for this quickly. Note pairs, but this. So the output is 7 there for this. So I think the 7 pair will be here, which will follow the conditions. So I think yeah, according to this would be the 7 pair would be there, which will follow this di plus dj condition. Guys, 1 minute. Let me just put the charger here. Turn on the charger. Yeah, so there will be 7 pair which would be passing the condition. So let's see, according to this, are we getting the 7 pairs? Let's see. So 0 will make how many pairs? 0 will make 2 pairs, right? 0 will make 2 pairs with 3 and with 5. Am I right? Let's see 3 with the 3. So 3 will make 3 minus 2, 1 pair. 3 plus 5, 3 minus 2. I think, yeah, 3 will also make the 2, 3 minus 2, 3 minus 5, 3 minus 1. It will also make 3 pair, right? Let's talk about minus 2. Minus 2 will make 1 pair with 5 only, correct? And let's talk about the 5. It will only make 1 pair. 5 minus 1, yeah, it will. So 3, 2, 5, 6, 7. Yeah, answer is 7 here. Let's talk about here with this array 0, 3 minus 2, 5 minus 1. Okay, we have converted into this one minus 2, minus 1, 0, 3, comma 5. How many pairs it will make? Let's talk about 5. 5 will make 0 pair, correct? Let's take 3. 3 will make 1 pair. Let's talk about 0. So 0 plus 3, 0 plus 5. 0 will make 2 pair, right? Let's talk about minus 1. So minus 1, how many pair it is taking? Minus 1 will make with this, minus 1 will make with this. So 1 pair, 2 pair. So it will make 2 pair, correct? Let's talk about minus 2. So minus 2 will make 1 pair with this, 1 pair with this. Minus 2 will also make 2. So 2 to 4 to 6 and 7. Answer is 7 here also. So that's why uh, but yeah, I will talk about it. I will think about it, why it is happening. Then we will. If you guys have any ideas, you guys let me know. But the result we are getting is from A array minus B array. So the index should be same, right, sir? Yeah, actually, on the indexes part, I'm just thinking why like I have to think about it. I've not got the point for this problem yet, where I could point out why is it happening. I have not got the point for this problem yet, where I could point out why it is happening. Vishal, I didn't understand your question. We want number of pairs or pair itself? We want number of pairs, Prat. Okay, now I got it. What is the reason? Yeah, here we are only counting number of pairs. Minus 2 comma 3 is invalid, but 3 comma minus 2 will also be there. So it is counting them as one pair. Oh, okay, okay. But that could be the reason for it. That could be the reason you are thinking, Likhit, that why we are not taking about the indexes. Everyone agree with that? That we are looking for the pairs. Yeah, but pairs are important. So, okay, I think I'm already filled with a lot of things. So that's why I'm not able to think straight. But yes, if that could be the reason, I will just take some more time to think about it, and then I could say that if that's the scenario. Okay. Okay, guys. So but yeah, let's not think about that right now. But other than that, let's talk about the code first. Or you guys want to see it after break? Okay, sure. But if the output need pairs also, then this sorting would be wrong. Because you are saying that because indexes could be the problem there, right? Correct. Okay, sure. Okay, guys, so we can take the 15-minute break. I know it was all heavy. I told you, right? These questions are tough to understand and explain also. So I will spend like whole days. I'm trying to explain it my best. But yes, I think you just try to understand little bit of that. And I'm again saying it's the base I'm also only giving. You guys have to practice it more and more. And I think we need more classes on understanding these problems. I think these 5 problems we cannot talk and discuss in 3 hours. I personally think that I will talk with Ansul to give us more classes to explain these problems a little bit more better way. Okay, so we can come back after break. So right now it's 9:42. So we could come back at 9:55. Okay, come back at 9:55. Yeah, I will ask. I will ask. Yeah, but yeah, with more classes, that's not the that will not help you more, but with more practice, that will definitely help you more. Okay. Today I'm explaining you pair of that. I want you guys to spend like 1 hour or more than that to just like draw the pictures, take different examples, try out things. Then only you can understand it better. With one example, you cannot grasp everything. Okay. There could be some edge cases which I missed. There could be some edge cases which I could miss. So that's why, guys, one solution is not fully like work is going to work everywhere. Okay. Sure. So we can come back now after break. Let's take 15-minute break and let's come back at 9:55. Okay. So like more people are joining. Meanwhile, you guys have any doubt? Let me know. So we have started with lower bound. Then we talk about upper bound, right? And after lower bound and upper bound, we have started understanding the logic of first problem, which was pair problems, where what we need to do, we got two arrays, and in that array we need to find out the pair of indices, number of pair of indices which passes one condition, correct? So they have given us one condition which was ai plus aj greater than equal to vi plus vj. That was the condition which they have given to us, correct? So what we did to there, we have tried to solve this problem. Rather than working on two arrays, we tried to create one array. And how we done that? We have brought ai minus vi at one place and aj minus vj at another place. Now both indexes at the same place, correct? And then we done the similar thing in the array also. Same indexes we have subtracted, ai minus vi, same indexes we subtracted, and we got one di. We have taken one new array, or we have given some new variable name to that ai minus aj, correct? After getting the di plus dj greater than 0, what we did, we tried to solve our problem. In the same array, now we need to find it out, the pairs which are going to pass this condition di plus dj greater than 0. What we did for that, we have two approaches. One is the brute force, where we can simply apply two for loop and we can just figure it out. But rather than that, that will be the complexity of n square. But rather than that, what we did, we followed the binary search approach. We have sorted the array. After sorting the array, we just try to figure out if there are positive numbers. So all the right side of that positive will be the pairs which are going to pass the condition. And if there is any negative number, we are going to find out the positive number on the right side, which could make our condition pass. That's what the logic, that's what the code which we need to do here, right, guys? So do you guys see any problem in that? Let me know in the chat, so I could go into that part and explain you guys again. Is everyone back now? Arad is back, Hariharan is back, great. Suraj is also back, great. Nilanjan is also back. Jayesh is also back, great. Okay. So Likita, you are also back. Today, I think what was her name? Asta or Shweta? She didn't join, right? Ekta, sorry, yes, Ekta. She didn't join today's class. I think you guys should not miss the classes. Otherwise, some of the small things you will miss in the recording, right? Okay, that's fine. So I think, I got this 10-minute gap, and I think about that sorting part, which I and Likhit were discussing, that will it make any impact or not? So I think yes, it will not make any impact, because the question was we need to pass the condition, which was the di plus dj greater than 0, right? That was the condition. Or if we are sorting that array or not sorting an array, the number of like element of that array will not change. Element of array are not going to change anyhow. Even if -2 is at the 0th index, like 3 is at the, like, yeah, take this example. I think, yeah, Likit was right. Not this one. Yeah, this one. So see, if we take this example, same example actually. Okay, it's being little slow. Okay, so see, 0 comma -3, -2, 5 comma -1. Even 3 is earlier than that, or -2 is later, 3 comma -2 will be one pair, right? According to 3, -2 will be one pair. Correct? So a pair, right? So that's why, and the same thing is happening here also. If -2 is here, if -2 is here, it could make a pair with 3. So 3 comma -2 or -2 comma 3 is going to give us same result. Going to give us same result. I think my system is little slow now. So, okay, let me close the things. My Can you guys see my thing? See my screen? Yes, Likit. That's right. Because the if we even if we are sorting our array, the elements of array is not going to change. That was the catch here. That was the catch here. That the elements of array is not going to change. They are going to make the pairs in any way. 3 comma -2, if they are in the array, if they are in any position, they are going to make the pair. So that's why according to our question, we need to find the number of pairs. I think I less than j is only telling us that we should not keep the duplicate pairs. I think it is only telling us I less than j means it should not give us the duplicate pair. Like 3 comma 5, if you have already counted 3 comma 5, you should not count 5 comma 3. That was the constraint. Only that condition is giving us. Okay, guys. That condition is only giving us that constraint कि अगर हमने एक पेयर को काउंट कर लिया है, so we should not count the same pair again. That's the reason only. If you have already counted 3,5 one time, then I think 5,3 will not come into should not come into your picture. That was the condition. I less than j, I greater than I less than j is giving to you. Okay. Okay, so let's see quickly this code. And I think I realized one more thing. Guys, are you able to hear me clearly? Because I am seeing some lag here in my system. Okay, you are seeing clearly. Okay, that's great. Okay, so one more thing I realized. Okay, video is taking. Yeah, I think something is happening in my system. It looks like it's also heating. Okay, so what I realized, guys, I think. Okay, if I will restart it. Yeah, so I just refreshed it. Let's see if it make any difference than earlier. Okay, so what I'm saying, guys, that because we already have the code for all the problems, so I think now the next 1.5 hours we'll try to go to each questions and try to understand their logic, try to understand the problem, try to understand their logic, because code and implementation is already there in the JS Fiddle. So I think once you guys will understand the problem and logic, I think after that you will spend your time in the understanding the coding. That will definitely make you like, that will definitely help you understand that question little bit better, rather than showing I will show your code, because already that code is there and that code is that much big. So rather than seeing that code, we will first spend whole our time, remaining time, in understanding the problems, because you have tomorrow full day. If you guys, if I will only explain two questions, you guys will automatically understand those things, right? You guys already understood this thing, you guys will not get anything new. So that's why I will first understand, first try to tell you guys all 5 problems logic, and then if we got the time, then we will see the coding part also. But yeah, for this code pair of topics, we will first see, we will definitely see quickly the code, and then we will move into the next question. Okay. Okay, so now let's see. You guys are able to see my screen? First tell me in the chat. Okay, you go there, hide. Yeah. You guys are able to see my screen? Yeah, definitely, Hariharan. See, Hariharan. Definitely, once you will understand the problem and their logic, you will very easily understood the code. But if you still face any problem, I will definitely explain the code one line by line. That's not because see, I already told you, right? The code we written, that is like one way to solve this problem. You can write the code in your ways also. So that's why it's better to understand the problem and the logic. And then if you are and then you guys should try to solve this problem rather than seeing the code. And if you still face problem, then see the code. Okay. And if you still not understanding, then I will explain you that. That's what I'm saying. Okay. So let's quickly see this part of code quickly, because now you have understood the logic. So let me repeat the logic again. And then we will see the code very quickly. It's taking a little bit. Is it happening with everyone? Okay, let me refresh it. Can you guys see me and hear me now? Okay, great. So see, for this problem, what we did, we got 2 arrays, right? And we got 1 equation. And they told us, find out the pair of indices, number of pair of indices, which will pass this condition, correct? What we did, rather than playing with 2 arrays, we tried to convert those 2 arrays in 1 array. And how we did it? According to our equation. So equation was AI plus VJ, AI plus AJ greater than BI plus VJ. We try to bring those BI plus VJ in this place, and then try to reduce this equation into one equation. And according to that, we also converted our 2 arrays into 1 array. Once we got 1 array, and in that only 1 array, we need to find out the indexes which would be passing our BI plus DJ greater than 0 condition. Correct? Then what we did, we have sorted our array. After sorting our array, all the positive element or all the greater element gone into the right side. As those positive and greater element gone into the right side, now we can easily say that according to our conditions, all the positive elements, their right side will also be positive. So we do not need to care about, we do not need to think about the positive scenarios. Wherever positive elements are coming, all the right side of that positive element will be passing the conditions. Those are going to fulfill the pairs rules. But wherever we are seeing a negative element, wherever we are seeing any negative element in the indexes, we need to find out the number which is going to make this negative number positive. We are going to find out the upper bound. In one way, we should say we have to find out the upper bound for that number, so we can easily find out that which number is going to make it positive and make our condition true. That was the logic only which we have discussed. Okay, let's quickly see this code and then we can move into the next part. able to see my screen? Okay, great. Okay, so you can see we have two functions. One is the binary search, very simple binary search, and second one is the get pairs. Correct? In that get pairs, we are passing those two arrays 48262, 5413, and we are passing the length of our arrays, correct, which is 5. Right? Now let's see what is happening inside this function. So the first thing which we need to do, that is we need to create a new array, and inside that array we need to subtract these two arrays, right? So that's what you see. I created a new array the same length, and I subtracted ai minus vi, and we got the the new array of with the subtracted element, like this one. If I go into the notes, you can see this array we got. It's loading. Yeah, this array 0, 3, minus 2, 5, 1. This array we got, right? With just one loop, we got this array. You guys can later see how these things are happening. You guys can also try, but yeah, we got the new array here. After that, we sorted our array. Sorting is happening. Okay, let's move down. Let me first come back to the screen. Let me see if you guys are able to still see my screen or anything problem. Are you guys able to see my screen? Okay, great. So see, now we got our sorted array. Now what we need to do? We need to first start from the right side, right? We need to start from the right side, and we need to check. So that's what I'm doing. I'm starting from the right side. I is good because we have already sorted out all the positive, all the greater element is on the right side. So that's why I'm starting my loop from the right side, and I'm checking if my element is positive. If my element is positive, I think I can put greater equal also. I can put greater equal also because I can allow 0 also there. So if my element is positive, so what I'm saying, I just simply take all the right side of it. Take all the right side of that index. So see, if my index is 3, like if we take this example here, if we take this array minus 2, minus 1, 0, 3. So if we talk about the 3, so take the all the right elements from that index. So that's what the happening here. N minus I minus 1. So n would be the length of array, I would be the index, or minus 1. So that's what we will get. Like see, in this scenario, n will be 5, index would be 3, 5 minus 3 minus 1. So 5 minus 4, so which will be 1. So this 3 could only make one pair. हम क्यों कर रहे हैं -1? That's why, because we are starting from 0 to n minus 1. So हमें 3 इंडेक्स मिलेगा, right? But we are subtracting it with 5, जो कि लेंथ है array की. So that's why 5 minus 4, this would be 1. That's why we are doing n minus 1 here. Correct? Now, अब ये हो गया positive scenario. This is the positive scenario. But in the case of negative scenario, if we got any negative scenario, what we need to do? We need to find out the upper bound for the minus element, minus di. You can see minus di. It means I am trying to find it out for, I am trying to upper bound for positive 2 or positive 1. जैसे ही हमें उसका, as we got the positive upper bound for that element, that mean that element we can add that element to this negative number and make it positive. क्योंकि देखो -1 को अगर हमें पॉजिटिव बनाना है तो हमें +1 से बड़ा ही चाहिए. करेक्ट? We need a number which is greater than +1. We need a number for -2 which is greater than 2. Only then only we can make make this condition pass, or this condition satisfy. So that's why we are looking for a number which are positive for the negative scenarios. And as we got the index, we are simply subtracting it in the length. You can check this part why we are not taking -1 according to the scenario here, whatever we are getting here. And then we are just adding it into the total. And this binary search is doing the similar thing. If you will see the binary search function, it is simply doing the upper bound scenario. You see where the a middle is greater than element, just high is equal to middle. So this is simply doing the upper bound. Okay, guys. So that was the code. That's why I'm saying once you understood the logic, this coding part, I would say you should try first. Okay. Yeah, find a value where it can make them positive. That's right. That's what we are doing. So that we will get only with the upper bound. That's what we will get in the binary search term. That element we will get only with the upper bound. क्योंकि upper bound हमको हमेशा उस element का उस element से बड़ी value देता है. Upper bound always gives us the greatest value, right? Greater index. So that's why. Okay, guys. Okay, so that was about find a pairs. Total is equal to n minus I minus 1. Not getting, sir? Okay, number of negative nums. Which one, Hariharan? Total is equal to n minus I minus 1. Okay, so that one, okay, let me tell you one more. Let's take a new page. -2. My marker is not working. This will create a problem, guys. If my marker is not working properly. 3, 5. So देखो, yeah, this is 3. I'm not sure what is happening with my marker. Okay, this is 3, right? Yeah. So see, Hariharan, somehow you got, like, see, we are yeah, I is starting from n minus 1 or n is 5 here. Oh, it's very weird. My marker is behaving very weird. So I is equal to 4, right? Correct? अब देखो, this is 3, right? अब 3 कितने पेयर बना सकता है? Only one pair with the 3,5. How many pair it could make? Only 3,5. Correct? So now, where we will match it, it will be I is equal to 3. Correct? At this position, we will get the 3. If we got the index here, 0, 1, 2, 3, and 4. Correct? So we'll get the 3 here. अब तुम देखो, अब हम now we want to count the how many pairs it could make. So we will do 5, this total number of element, minus 3. The first thing we can do this, but you can see 5 minus 3 is equal to 2. This cannot make the 2 pairs. It can only make the 1 pair. And why we are taking the index? We should take the exact number of element, because we are comparing with the number of elements. Number of elements are 5. So we should be comparing from that. So that's why 5 minus 3 minus 1 is equal to 1 is equal to 1 is equal to 1. Oh, see, another way to understand, because we are starting from 0 to n minus 1. Another way to understand, we are starting from 0 to n minus 1. This index is already less than. This index is already less than. देखो, अगर हम ऐसे एलिमेंट काउंट करें 1, 2, 3, 4, 5, अब तुम देखो ये इंडेक्स तो ऑलरेडी एक कम है, it's already less than the original index, right? So that's why it will only make, that's why we are trying to subtract -1. This is the logic part actually. If you will try it, you will understood that we need to subtract it -1 also, because we are starting from the 0th index. Okay, Riran? Number of pairs is equal to number of elements after that number. Number of pairs is equal to number of elements after that number. Number of pairs, if we are, how will it will be number of elements? No. That's not the minus di part. See, Hariran, for a negative number, we are trying to find a positive number. For a -2, like there is -2, correct? So we are trying so और हमारी कंडीशन क्या है? What is our condition? di plus dj greater than 0. तो हमें क्या है, अपनी इक्वेशन को greater than 0 करना है. अब -2 तो नेगेटिव है, so we need to find something which could make -2 positive, and which is only 3, like which is only the greater number than the positive number of -2 or the mod of -2. So if we see -2 plus +2, it will make 0. It will make 0. But if we take any number greater than +2, which will make our condition which is greater than 0. So that's why we are trying to convert all the negative to positive first. We are trying to convert all the negative to positive first. Then we are trying to find a greater number than that positive, or the upper bound for that positive number. That's why we were trying to do minus di, because we want to find out the positive number, positive or greater than 0 number for that negative number. Simple example of -2 ka. -2, take the simple example of -2. How could you make this greater than 0? You can only make with the 3 or 4, the number greater than 2. इसका मतलब उस -2 को पॉजिटिव में ले आओ और उसका ग्रेटर दो, किसी भी नंबर को, any number. If you have any negative number, if you want to create a positive number of that, you can add same number. But if positive number and greater than 0, you have to take you have to find out the number which are going to be greater than the positive form of that number. Okay, Dhiren? Very simple math. Just try to compare with the math little bit. Okay, great. Let's move into the next question now. Okay, this is our next problem. Square using binary search. Okay, so let's see. And I'm just praying this should work properly. Otherwise, it's very difficult to explain. Okay, let's read the question quickly. So they are saying we will get a positive number, and we will give a precision, you know, the decimal part after a number, which we have the decimal part, right? And we need to find the square root of number up to decimal places using the binary search. Okay, so see, they have given also the examples. We have a number 50 and their precision is 3. So they want a number like the square root till 3 precision, right? Same goes for 4. Like after decimal, how many numbers will be there? Correct? That's what they are looking here. Okay. So see what we will do here, guys. Let's write out our number here. Let's first take the which is like positive, which have a square root. These are all the all the numbers. So okay, you guys know about the square root, right? Square root is like this one. In the math, we say underscore 25, like root 25 is equal to 5, 36, 6, 4, 2, right? You guys are aware of this, right? The square root part. Everyone know about this in math, right? Great. Okay, so that's what. So see, okay, so this would be 6,2, and this would be our square root of that. Correct? So let's see what we can do here, guys. For first think about if we want to get the square root of 25. So see, square root will always be lesser than that. There would not be any square root number which is going to be greater than the number. Like if you take any square, even under 36, it would be 6 underscore 4 is equal to 2, because we calculate the square root by multiplying same number. Square means 2 times. You multiply the same number 2 times, you will get the square value. You see, underscore 25 is equal to 5 multiply 5. Underscore 36 is equal to 6 multiplied by 6. Underscore 4 is equal to 2 multiplied by 2. Correct? So what we can see from here, somehow if we get a number, if we guess a number, like we are guessing any number, or if that number, if we multiply same number with same number one more time, and if we are getting our square root, then that could be our square root number. See, very simple. somehow like we are guessing any number. See, हमें पहली चीज पता है, we know first thing that the square root for 25 could not be greater than 25. That thing we know. So we could start from 0 to 25. That could be a range, right? That could be a range, that the square root will be between this. Correct? अब देखो, अब हम क्या करेंगे, or this is you can now relate this with this little bit with the binary search also. In the binary search we got our left, we got our right. Now somehow if we got any mid, some like consider 0 plus 25 divided by 2, which would be 12. So in the 12, in the index 12, number will also be 12. So somehow if we multiply 12 multiply 12, or if this is equal to 25, we can say that this is our square root, right? Right now we are getting 12, but if we got 5 somehow, so we can say 5 multiply 5 is equal to 25. We can say that, right? This is our mid. Where how can we get the mid? How can we get the square root? We can say wherever my mid and mid, if multiplication of mid is equal to my square root number, which we got, we can say that number, that mid could be our square root. That mid could be our square root. That mid could be our square root. अब देखो हम यही करने वाले हैं. In the binary search, that's what we are going to do. We are trying to find it out, that number which could be equal to 25 or less than 25. Because अब यहाँ 25 केस है, अगर यही 26 होता, if that is a 26, then still the root square would be less than that. Like if we take 6 cross 6, 36. This now 6 could not be square root for 26. That will be definitely 5 cross 5 equal to 25. So like something in the decimal, that will be the square root for 26. But the integer part of that square root would be 5 only. Integer part of that square root will be 5 only. Okay, so see, that's what we are going to write. We are going to find out the mid is equal to 12. हम फिर उसका multiply करने वाले हैं. 12 is equal to, if that multiplication is greater than, if this multiplication is greater than our square root, which is 26. If this multiplication is greater than square root, we need to move into the left side. We need to move into the left side. Correct? So we will do right is equal to mid. Right is equal to mid. Or if it is a lesser than, then we need to move into the left is equal to mid plus 1. Or we will do this thing till we found our square root, or left is greater than right, or left is greater than right. और ये तभी होगा जब हमें small number मिल जाएगा. We will get a small number than square root. In 25 case, we will get 5. In 25 case, we could be getting 5 or 4. We could be getting anything here, right? And or in the 26 case, so see, we will be always getting a mid, which like if we multiply 2 times that mid, that would be equal to 26 or less than 26. That could be the condition. We will always get a mid which would be equal to square root number or less than square root number. Okay, that's the actually logic for the integer part of square root. First, let me know in the chat, you guys understood a little bit about it or confused? Let me know about your confusions, about your doubt. Yeah, understood. Okay, Arad has understood. What about others? Vishal has also understood. So that's what we actually guys we need to do on finding out the integer part. Finding out the integer part. हम क्या करेंगे? We have the range, right? हम always, this is the mathematics thing, कि हमेशा स्क्वायर रूट जो होता है नंबर का, वो हमेशा नंबर से कम होता है. स्क्वायर रूट का मतलब ये है कि हमने उसमें डिवाइड कर दिया है. स्क्वायर रूट का मतलब ये है हम उसमें डिवाइड कर देते हैं, हमेशा वो नंबर से कम ही होता है. दिस इज द मैथमेटिक्स थिंग. ओके, वंस वी गॉट दैट, वी गॉट द रेंज नाउ. We got the range now, 0 to that square root number, which were we finding out. Then once we got this number, we have to guess. Now we have to guess. Somehow, if we get any number and if we multiply with the same number, like if we are guessing any number and if we multiply same number 2 times, like the same number again, then if we are getting near, if we are reaching near to our square root, then we will say yes, that could be our square root number, or that could be the integer part of square root number. Okay, trying to understand, not getting fully. If you can repeat. Sure. Niranjan. So that's what I where was that? Yeah, it's here. See guys, so this is our, let's take again 25. I told you is very easy. The first way, do not think about all this mid one, all these things, right? So think, let's see. So like the square root of 25 is 5. Mathematics, square root of 25 is 5. So अगर हमें ये 5 मिल गया है, तो हम स्क्वायर कैसे निकालते हैं? So we just do 5 multiply 5 is equal to 25, right? These two things are same, right? Square root calculate in this way only. So now we can use this logic in somehow in the programming way. So what we did, so we got the range 0 to 25. Now we need to guess. Now we need to guess a number between 0 to 25. Like we can guess 36 also. We can guess 7 also. We can guess 17 also. We can guess 20 also. We can guess 9 also. Any number between 0 to 25. After guessing that number, we need to follow the same logic here. How can we get this square number? We have to multiply the same number again. So we have to multiply the same number 2 times. So that's what. If we got 9, so we need to multiply 9 multiplied by 9. We will get 81. We'll see. This 81 is equal to our square root number? No, this is not. It means this is the wrong guess number. We need to look for some other number. अब देखो हमें, क्योंकि we already aware of the binary search, so we can easily say that if our if our number is greater, if our multiply number is greater than the result, we have to look for the left side. It means we have to look for the lesser number. So that's what the binary search is giving you. Otherwise, in any other way, you could now go for 12 also. But binary search is suggesting you should not go now for the right side. You should go for the left side. So that's why now next number you can guess 6, because it's the left side hai. So 6 multiply 6, 36. You see, still it is greater. What binary search is again suggesting, go on to left side again. You went for 5, 25. You got it. Or if this is not a, now you can say, now this mid is the correct guess number. This mid is the correct guess number. Okay. Or if this is not the 25, it's the like 24. Still now 5 will not be your, like 5 will not be mid, because 25 is still greater. Binary search will again suggest you go on to the left side. Now you will go for 4. 4 multiplied by 4, which would be 16. Now you will stop it here. You will say this 4 is the integral part, which we are going to use for 24. Okay. Okay, Nilanjan? Understood now? Everyone? Okay. After understanding this, what for 28? You tell me, what for 28? It would be greater than 5. Yeah. Yes, Suraj. It would be 5. It would be less than 6, because 6 multiplied 6 would be 36. हमें lesser जाना है. So that would be 6. Yes, less than 6. Right, 5. It would be 5. Correct. Okay, let's see for the precision part. अब क्या precision क्या होता है? What is precision? So how we will do that? That is easy actually. That is simple, easy. So once we got our number like 4, so now we need to do the precision here. Or how many times we need to do the precision? Like so they will provide you 3 times or 4 times. So what we need to do in precision, we will take one variable increment, because we need to increment, right? 0.1. So see how we will increment. So the precision looks like this: 4.1, 4.2, 4.3, 4.4, 4.5, 4.6. This all could be the precision, right? The first precision. There is 3 precision, right? Like 3 precision means three decimal numbers will come at the end, but we will start with first number and we will decide which 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 numbers square is less than our target, less than, like, let's take example of 24. In 24 we got 4, right? So 4 minus 1 square, is it less than 24 or equal to 24? हमें तब तक यहाँ पे ये नंबर डिसाइड करना है जब तक हम लेस देन में रहते हैं, जब तक हम लेस देन 24 हैं। जैसे ही हम ग्रेटर चले गए हमें वो नंबर नहीं लेना है, we will not take that number, we will only take 4.6. Let me open the calculator if I have. Let me open the calculator very quickly, or we can open it into the Google also for the precision part. Calculator online. So see, we'll try for 4.6. We'll see where we will stop for 24. Okay. Oh, I was not writing it. 4.6 multiply by 4.6. What are we getting? See, 21. We can still go further, right? We can still go further. How will I change it? Okay, I think better is that directly write it. 4.7, 4.7. See, 22. We can still go further. 4.8. Yeah, 23. We can still go further. 9, 9. Now 24. Now it is increasing. We cannot go for 4.9. We need to stay for 4.8. Right, guys? So now here, the first precision would be 4.8. So 8 will come here. Now we need to go for next one. So now it will be 4.81, 4.82, 4.83, 4.84. This is the next precision. Again, we need to do same square of it. And then we have to check for less than our square number, less than our square root, which is 24. Okay, guys? And wherever, like I'm just guessing, it could be in the 3. So now we'll stop it here. Now, because we need one more precision, so we'll go for one more time. 1.831, 4.832, 4.833, 4.8334. And here again we need to do a similar thing. Square less than 24. Square less than 24. Square less than 24. Square less than 24. Or wherever we find it, we'll say that that is the number, and that could be our answer. Okay, let me, I know this is a little bit mathematics, but yeah, tell me, did you guys understood or not? Yes, this will work for perfect square also. Yeah, it was easy actually, yeah. If you want to, guys, quickly see the code also, so I will show you. Square root. See how the precision is happening. So I have taken the precision loop here. You guys are able to see my screen, right? Yeah, let's just quickly see the precision code. So I've taken the like the precision 3, and then again just doing the multiplication. Answer into answer less than equal to number. Answer into answer less than equal to a number, and then we are incrementing it. So first time it would be, see, or increment हमने क्या लिया है? Increment we have taken 0.1. So every time, first time for like 4 would be there. Then first time we will add 4.01. Then square of 4.01 less than equal to number. If yes, again go, again go, again go, again go. और हम ये कंडीशन कब खत्म कर रहे हैं? जब हमारा आंसर एंड आंसर बड़ा हो जा रहा है नंबर से, लाइक 4.19 पे, 4.9 पे हम खत्म कर रहे हैं कंडीशन, 4.9 पे ये कंडीशन खत्म कर रहे हैं. So that's why I was increment like subtracting the increment, so it could come into 4.8, and as we got into 4.8, we are increasing the increment to /10, because if you will divide 0.1 by 10, it will become 0.01. अब ये सेकंड लूप चलेगा यहाँ पे 0.01, अब ये इसमें ऐड होगा, and again for the third loop we again dividing it 0.001. Very easy logic. You will just read this logic, it's very easy. And here you can see on the top, mid into mid is equal to number. तब हम कह रहे हैं ठीक है आंसर हमारा हो सकता है वो, हम तो वहां पे ब्रेक कर दे रहे हैं. और if mid and mid less than number, we are incrementing also, or we are thinking that this could be our answer. So you guys can later look into this code. We can now jump into the next one. Okay. Now we can look into the next one. Okay, instead of less than equal to, we can write less than. For this one, you are saying? For this one, you're saying for less than. Oh yeah, for that scenario, we do not need to write this one then, right? The 53 line number. Yeah, that could be. Oh, okay. You want to see it? Okay, very quickly. Somebody has shown the interest for. Okay, so let's run it. Node square root. We are looking for 9. Let's see. So it is giving us 3, right? The square root of 9 and 4 precision. So because this is the square root, so let's look for any other number like 10. Like we were looking for 24, right? Yeah, 24. Let's see. Are we close? Yeah, see, 4.89888888. It is not giving 4 precision. You guys can look into later why it is not giving us 4 procedure. What I'm printing it here. Okay, returning. So returning is increasing these zeros or what? Let's console it here. What we are getting here after precision? Answer. Yeah. Let's remove it. Or there is some problem in the loop. Oh yeah, it looks like there is some problem in loop. So we can check this later part. Yeah, you guys can check this part. But yeah, something is happening there. We should use two. No. JavaScript method we are not going to use, Arad. That's what the thing we are trying to do here, right? We are trying to avoid most of the JavaScript inbuilt functions here. Yeah. Yeah, Likit, I think we should get 3.00, but not sure why it's happening. I am missing anything. I have not touched anything here. But yeah, that's the logic. I think you guys can look into that later. Otherwise, I will just look into that. Yeah. Sure. I think you guys can look into that. Discord, I will push it, and then you guys can look into that later. We can now go into the next question quickly. So there would be something for you guys to practice it. Okay. I think the next easy question which I remember, because this is tough number of sextuplets. Splitting an array is also tough. Subsets is also tough. I think we can go for triangle, not a triangle. This one is easy. We can complete this one very quickly. Okay. We can understand this logic also. And then we can, if we got, I think we will end it today here, this part, and then we will go for next part. Next class, we'll go for the next questions. Okay. Let's look for not a triangle. So what they are saying, you will be given a list of number 1 to n. Okay, each number is considered as a one stick. Okay, the ith stick will be having a specific length. So they are saying inside the array there will be inside of one array there will be sticks which have, and those sticks are representing the length of those numbers are representing the length of that stick. Okay, and we need to play a game in problem. We need to pick 3 sticks randomly, and if our opponent is able to form a triangle using those 3 sticks, he will win. And our task is to find the number of ways to select 3 sticks such that it's not possible for our opponent to form a triangle using them. It could be a little bit confusing while reading them, but very simple. You can read it here. 4 to 10. This is one array which they have given to us, and we have to find it out that is there any possibility he cannot make a triangle with these 3 numbers. Is there any pair in this array with that pair the person could not make a triangle? And there is a property in a triangle. If we add 2 numbers, and if the addition of these 2 numbers is like I think less than the third number, like in the triangle we have 3 sticks, right? If we are choosing 3 sticks, so if we add 2 numbers if those two numbers are less than the third number, then I think that we cannot make a triangle. That's the property I think triangle have. Let me see. Is that is not getting, we'll check these possibilities. We want to sum of two numbers less than 3 1. Yeah, I think see, we can find triplet in which the sum of two numbers is less than the third one. So देखो property होती है I think कि in a triangle if we are taking two numbers, so addition of those two numbers should be greater than third. If that's the property, if it is if we have these properties in all three numbers, we can create a triangle. But our problem is we have to find a pair. We should not be able to create a triangle. So our condition is little bit opposite. We need to find a two number. We need to add those two numbers, and addition of those two numbers should be less than the third number. That's what we need to do it here. Did you understood the question? That's why, guys, these type of problems, it's very difficult to understand the questions also. So first, try to understand the question. So question is here, we will be getting one array. In that array, we need to choose a pair, and that pair will be of three elements. We need to choose a pair of three elements. In that pair, we need to add a true number, and those addition of like sum of those two number should be less than third number. If that is the case, we have to return the result that yes, this is the true scenario. That's what we want. Okay. So Arad is saying addition of two smallest side should be greater than third side, else it won't be triangle. Yes. Addition of two smallest side should be greater than three, greater than third. Yes, we need to eliminate what we are having in our combination that satisfies the triangle rule. We need to eliminate what we will have. Yes, that's right. We need to find those. We need to find those. Eliminate. We need to eliminate what we will having in our combination. Yes, that we can say that. We need to eliminate. We need to eliminate. Yes. So see, repeat. I'm just repeating again, Suraj. So first understand the triangle property. So the triangle property is in triangle there would be three vertices, right? So the triangle property is the sum of two vertices should be greater than third vertices. Sum of two vertices should be greater than third vertices. Okay. So ये होता है triangle की property. But हमें ऐसे pairs we have to find out that type of pairs which should not follow this property. So sum of two pairs should be less than third vertices. That's what we need to find it out. Sum of two vertices, triangle property is sum of two vertices should be greater than third vertices. But we need to find out sum of two vertices less than third vertices. Okay, that's what we need to do. What will happen if it is equal? So what if it is equal? We will say that this is not the true case. This could make a pair. Like we can in the equal scenario. So 1 1 2, right? 1 1 2. 1 1 2 in the equal scenarios. Not sure about that. What will happen? But yeah, in equal scenario, we are going to reject it. Because our condition is very simple. Our condition is our sum should be less than. Agar less than nahi hai, we are going to reject it. We are not going to add that pair into our result. Okay, Ariyaran? We are going to simply reject it. Okay, so let's see what we are going to do it here. So that what they are saying, sort the given input array, create a nested loop having first iteration will be from array 0 to n minus 1, second iteration will be from I plus 1 to n minus 1. Okay, n square to abhi ho gaya hai. It is already n square. And then take the sum of both elements in a nested loop and check if there is any number exists which is see. Okay. See, according to brute force, अगर हम इसको brute force से करते, if we are trying to do it through brute force, so see how we will do that. I think they have reduced only one loop. So see, according to brute force, अगर हम array लेते हैं, same array ले लेते हैं. Are they giving any array here? Yeah, 4 to 10. let's take this one, 4 2 10. According to brute force, what we will do, guys, we will first add 4 2, right? Then we will take a third loop. Like first will be there will be first loop, first I barabar 0 to n minus 1, where we will get 4, right? And then second loop will start from here, 4 plus 2, right? And then there will be third loop for 10, because 4 plus 2 plus 10, correct? And then we need to compare it, like 4 plus 2 plus 6. 4 plus 2 is equal to 6, and then we need to compare it with compare it with the third element, 6 greater than 10. In that, let's say bigger array. Actually, this is not making much. This is like giving, because we can simply in one iteration we can do that. So let's take little bit bigger array, because we need to find out the pairs. Okay, guys, this is a very small array. So let's take a little bit bigger array. Yeah, let's see if I had any example in my scenario. Oh, I also have the same. Okay, so I have taken this one. Okay, 2569. Okay, let's see, 2569. Oh, I think then what's the need? I think, see, in the let's take this one only. Okay, we will not divert from here. So see, in how we will do it in the if we have this question, if we want to do it through the brute force. So I believe what we will do, we will first it because we need to find the pairs, and that pair is for 3 elements, correct? So somehow we need to look for start from the 4, and that could be the first pair, 4 comma 2 comma 10. This is first pair. The second pair could be 4 comma 10 comma 2, right? Third pair could be 10 comma 4 comma 2, right? And more pair could be I believe 2 comma 4 comma 10, right? These type of pairs could be there. And then I think the how we will create these pairs. I think we have to run the 3 loops here. So first loop will be starting from 4, and all the pairs which we could create with the all the pairs which we could create with 4s, we will go for that. Then we will go for 2. Then all the pairs which we could create, we could go for that, right? I believe as we will do that. Let me think. Let me see you guys. What do you guys think? See, let me read their question again. Yeah, they have mentioned it. You can see they are saying that iterate 3 loops and verify that if there is a triplet such that sum of 2 number is less than the third number. Less than the third number. Oh, okay. See, I think yeah. Okay, I think yeah. I think we can do this like this. Okay. No need to like think about this. I didn't read that one. See, this will be like this. For I is equal to 0, I less than n, I plus plus, and then there would be third loop, j is equal to I, j less than n minus 1 or n minus 1, fine, okay, n minus 1, and I j plus plus. And once we got ai plus aj, we need to run third loop now. We need to run third loop. And in that third loop, which will be running like k is equal to 0 to k is equal to k less than n minus 1 and k plus plus. And we need to look for this sum is less than anywhere. 4 plus 2 is less than anywhere, any number in the k. Like this will be looking like this: ai plus aj less than ak. Or if anywhere this condition is passing, we'll say I comma j comma k is a pair which is going to solve which will follow, which will violate the triangle property, right, guys? This would be the brute force only. Did we get it? right? Already tried this, but this is giving, what is that, TLE? In a square problem, it is giving 4.1 plus 0 is giving 4.1999. I think it's a JavaScript variable who is trying to do some problems there. So I will look into that. Okay, Liquid? I look into that. Yeah. So guys, in this question, so what they are saying, we will still follow the two loops. But I think for the third loop, where we are trying to search for here, where was that? For the third loop, they are saying for this loop, we will not try to go with the loop here. We will try to go with the go for the binary search. So first we got the sum. So now what do we need to do? First, once we got 6, we need to iterate into this array, and somehow we need to find that the is there any element which is greater than 6? Is there any element which is greater than 6? Or as we find it out, then we can say that yeah, if we find it out, then we can say that there is one pair which exists, right? Let me see quickly in the code. Am I saying right or not? Yeah, count greater. If it is a greater, AI plus is a 1 minute, guys. What we are looking here? Am I like? Are we looking for lesser or greater? I was just confused here. Are we looking for lesser or greater? 1 minute. So 4 plus 2 less than 10. Yeah, we are looking for lesser, right? We are looking for lesser, right? So we have to look for the lesser element, right, in the array. Yes, I think yes. Oh, I just got confused. Oh yeah. Oh yeah. I think yeah. Yes, I was right. Like, see, we need to find it out. Once we got the sum 4 plus 2 6, we just need to find it out if there is any number which is greater than that. If that is the case, then our condition will fail, right? Because we need to look for the greater number, right? That is our condition, right? We need to look for the greater number. We need to look for the greater number. If we got any greater number, then it means that this is violating the triangle condition, because triangle condition is that only, right? You see, 4 plus 2 less than 10. So if we got any a greater number, so I think this could be similar to, I think if we sort this array 2 4 comma 10, so I think it would be similar to finding upper bound, right guys? It will be similar to finding upper bound. If we find the upper bound, then we can say that for this particular pair, for 2 comma 4, there is something which is passing the condition, am I right guys? Let's take any other example. 2359. I was just working with that, right? 2359, 2359, correct? So let's see, 2 plus 3, which would be 5. अब हमें we need to find out a number in the array that could be greater than 5. So yes, it is there. There is one number 9, right? So the count would be 1. There could be one pair which could violate the triangle condition. Let's take another other one, 3 comma 5, which would be 8. So I think yes, there is there is number which is lesser than that. So there could be count 2. Then if we can take 2 comma 5 also, right? To 2 plus 5, which is 7. Is there any greater than that? Yes, I think we have the 9. So I think we can say count is 3. So we have taken 2 comma 3, We have taken 3 comma 5, we have taken 2 comma 5. Let's take 3 comma 5. 3 comma 5 already taken. Okay, 3 comma 9. 3 plus 9 is equal to 12. Is it there any greater number, any number which is greater than that? No. So this will not be, this will be false. This is true, this is true, this is true. But this will not be true. Let's look for 2 plus 9, which is 11. This is also false because there is no greater number than 11, right? And let's look for 5 plus 9, 14. No, so this is, their answer should be 3. Let's look for the answer. No, we are looking for 2, 3, 5, 9, right? Oh, 2, 3, nahi hai, 2, 5, 6, 9. Let me write it. 2, 3, 5, and 9. Let's see how many answers are coming here. Note triangle.js. See, 3 are there. Okay, guys. So see, क्या करना है हमको? हमें upper bound निकालना है. Once we got the addition of starting 2 elements, we just need to go for the upper bound. Once we got the upper bound, we can say that this is going to be this is going to see. Okay, please repeat. Okay, see, this is the array, right, Hariharan? 2, 3, 5, 9. और हमारी ट्रायंगल की कंडीशन है, if we add two numbers a plus b, it should be less than the third number. It should be less than the third number, which is c. I'm not sure this could make more confusion to you. Wait. You just simply remember our triangle property, for violating a triangle property, our condition is if we add two number, the sum of these two number should have a greater number. Should have a greater number in this array. Very simple. Sum of two number should have a greater number in the array. अब देखो 2 plus 3, the sum of these two numbers are 5. So do we have anything in the array greater than 5? Yes, we have 9. It means it is violating the condition. It is violating the triangle condition. Okay, now let's look for 2 plus 5. 2 plus 5 is equal to 7. Do we have any number in the array which is greater than 7? Yes, we have. It means it is violating the condition. Let's look for 3 plus 5. This is two numbers we taken. 3 plus 5 is equal to 8. Sum of these two numbers, do they have any greater than that in the array? Yes, we have 9 in that. We have 9 in the array which is greater than 8. So it means it is also violating the condition. But look for 3 plus 9. 3 plus 9 is 12. Do we have any number in the array which is greater than 12? No. That's why it is violating the condition. That's why it is not violating the triangle condition. It is not violating the triangle condition. That's why we will not add it. That's why we only add these three scenarios. Okay, guys? Okay, Riren? So look at this thing, just count the sum of two pairs and search how many elements are there where those elements are greater than sum. And add, yes, that's what we need to do, Likit. That's what we need. So already I will push these changes. So let me push these changes. I'm already pushing other changes also. So let me first create a new branch. So git stash, 1 minute, git stash, git st, okay, great. Let's go for new branch, which would be git checkout minus v. I'm just giving it like day 2. Okay. Now we are in the git day 2. Let's push this branch. Git st. Now let's add these changes. Git push. Yeah. Now let's first share my GitHub repo, not the PayPal one. DS Alog. What was the name? Yeah, this one, right? DS Alog. Let me go to the day 2 branch and let me share the URL with you all. Oh yeah, we need to sort it, Vishal. We need to sort it. We could sort it. We could sort it earlier only. Before going for the loop, we can sort it there only. We have to find 3 elements from that 4. What is 4 element? A triangle has 3 sides only. Yeah, so yeah, that's right. From that array, we need to only pick 3 elements. Okay. And because array is sorted, we can stop iterating when we encounter the invalid case. When we encounter the invalid case, like 3 plus 5 is equal to 8. No, but we still have to go to, right? For finding out, we have to go to binaries. We have to go for upper bound, right? Still, we have to go for upper bound, right? Finding out that is there, does there any exist? 3 plus 5 is a true case, right? It's not invalid case. It will add elements into us. 3 plus 5 is equal to 8, and we have 9, right? So this is the true case. He means every element after that one will be greater. Okay. Oh yeah, I think yeah, there could be other ways also. If you are thinking like something like we were doing in the pair of topics, so yeah, we can relate something there. So I think yeah, guys. So we have I think discussed three questions today. I think the square one and pair of topics and the knotted triangle. I think logic wise we have discussed these 3 things, but still a lot of things you guys have to do it there with the coding part. I already pushed the changes and it looks like there are some problems like in the precision one. In the precision one, we were seeing some problems, right? So I will look into that part. And I think if you guys see any other problems in that one, so you guys can communicate to Ansul. And Ansul can tell me about that, that you guys were seeing some problems in other 2 problems also, like pair of topics and the knotted triangle. Okay, so he will be informing me. So okay guys, so sure, I will check that part if the round is needed or what is the problem there. It looks like me the JavaScript always what do we say, behave differently with the float number. Always behave differently. Whenever we are adding any float number in the JavaScript integers, it always behave differently. So that's why that could be the reason that we were facing the problem 4.111199, not with the 4 precision. So we have to check. I will look into that one. Okay, and I'm damn sure that's the only problem. The logic is correct. Okay, because mathematically we have done the same thing. Mathematically we have done the same thing. So we are trying to implement the same mathematics into the coding part. We are trying to like check for the square, and then once we are checking it, we are just dividing our increment by 10. So doing the same thing mathematically also. So if the code is behaving strange, it means something JavaScript or variables assigning is doing there. Okay, guys, so that's all for today. I know, definitely, I know a lot of things like whatever we discussed today, it would not be fully clear. But I believe you guys have understood little bit logic part. Wherever, because these questions are not easy. These questions were tough or medium. These questions was hard or medium categories. And whatever 3 questions which we have left, all 3 questions are hard. Okay, and some like there was one question like I think splitting an array. I spent more than half an hour to just understand the question. To just understand the question, guys. I think more than half an hour to just understand the question, and then after understanding the question only, I went for the logic or tried to look for the code. So I think in the next class we are going to see the next 3 also. and I will ask to Ansul to give us one more class to discuss, because there are 5 more questions in the next class. I have not touched those 5 questions till now. Yes, I think these questions could be asked in the interviews, like, and these questions are asked in the like tier one companies like Facebook, Amazon, Google. These questions are that much level actually. I think the smaller companies like tier three companies or tier three companies to tier two, they will not ask these much difficult questions. They will ask like not a triangle. This could be easy question. This is the easy question I would say, not a triangle one, or like the square root precision. That's also easy one. Like you will just try to look one or two more times, and you guys will figure it out. AI plus VJ, that could come in medium. That could come in medium, I would say. But like not a triangle and a square one, I think that could come in the easy state. Once you will understand, next time you will solve these type of questions easily. But the next three one which we are going to discuss, those needs a lot of coding. We will see that. I have already pushed the code if you guys want to see, but I already you guys have the code in the slides also. But yeah, that's fine. We'll see. We will understand the logic. We'll do the practice. We will not like lose hope. Do not lose hope. All things, all like difficult things comes with learning and practice. See, somebody has done this, right? Somebody has already done it. That's why we are able to solve it. So if somebody can do that, we can also do that, right? We are not like lesser than anyone, right? We are also eating same something, everything we are doing same. If somebody has done this, we can also do that. So just keep that hope in your heart or in mind, and with the practice, we will understand everything. And I think, see, I think that's good. Reliable is giving you 10 questions, and everywhere you will see the same logic. Everywhere you are seeing the binary search. See, you have solved 3 problems. Somehow in your mind, you will get the hit that binary search could do this thing, binary search could do this thing, binary search could do this thing. Wherever we are trying to see, that's why I explained you upper bound and lower bound. You can see in a lot of places we are using upper bound and lower bound. That's why I have explained you in the earlier only. So in the problems, somehow somewhere people are saying we need to find a greater number than that or lesser number than that. You can simply use the binary search, because where you need to find the upper bound and lower bound. So yeah, I think I'm like, I tried my best to explain all these 3 problems. And if you guys face any problems in these 3 things, we can discuss it in the doubt class also. And I would request you to please, if anywhere you see problem, please watch this recording again. And while watching this recording, try to see the code which we have implemented, and try to implement in your like, take a copy pen, whatever logic I have explained, try to do the same thing, repeat it. Take the pair of topics question, try to think what I did, what I explained in the class. Try to write the same thing in the page papers, right? After that, try to take a small part of that, like 2 arrays, try to subtract that array with code. Do small things in code. Do not copy paste. First, take 2 arrays in one function, try to subtract those 2 arrays with one loop. Once you got 2 arrays, now sort that array. After sorting, try starting one loop on that to get the maximum only, like the maximum index element, where is the positive index element. Try to do that much. Once you are good with that, put console there, check for that values, then go for the binary search. Same for the square one. Try to find the mid, and mid is like, see, I remember right now, mid and mid is equal to square number. Try to do that logic first. Try to find out the integer part. First, once you got the integer part, then go for precision. So that's how I think I try it, and I will suggest to everyone. You guys also try it. Do not lose hope, and don't think that these are too much difficult. Try to practice. If you will try to practice, you will be perfect very soon. Okay. Okay. So I think that's what all whatever things I want to say, and we will meet in next class. So have a good night, everyone. Have a will and do please do more practice. Very good night, everyone. Very good night, Vishal.